Second workshop on future of advanced air mobility. Thank you very much for coming. This is a workshop organized by IMO3D project. This is a project funded by the Spanish government, specifically by CDTI, and it's formed by 4 technological centers: CATEC, ITG, AICIA, that is linked to the University of Seville, the School of Engineering, and NAITEC. And well, first of all, CDTI, who is the one that is funded the project, has been very kind that it opened the session. So please welcome Roberto Rodrigo, who is the head of the Large Installation and Dual Programs Department. Thank you.
Bueno, pues muy buenos días. Voy a empezar con unas palabras en español y luego voy a continuar en inglés. Vale, me gustaría en primer lugar dar las gracias a los organizadores por darnos la oportunidad de dirigiros unas palabras en la bienvenida de esta importante jornada. Y en segundo lugar, disculpar a mi jefe, Juan Carlos Cortés, que se suponía que tenía que estar aquí hoy, pero que por motivos de agenda no le ha sido posible. Y bueno, dicho esto, cambiaré al inglés. So, good morning to you all, to this very interesting and very important workshop in a topic which I would say it's a very hot topic nowadays. I have a short presentation that I would like to use. Maybe I don't know if I can start with this. Oh, okay. All right. So, just a few words to put this workshop in its context. So, the Spanish aerospace sector for us is a very strategic sector in Spain. We have a wide range of capacities available. We have companies which that are in charge of equipment, of large systems, even complete airplanes. We have capacities in terms of ground infrastructure and, of course, test and R&D facilities. We believe it's a sector with a high added value and quality of employment, and with a high private investment in R&D. So for us, it's a very important sector, and traditionally in CDTI, I think we have been putting a very strong focus in this particular sector along the past 20, 30 years, so in the different parts of it. So I think that as part of this sector, this new field of advanced air mobility and the field of unmanned air vehicles and so on is really a very important part of this aerospace activities nowadays, as you know. So there are a very high number of projects going on in different fields, and it's for sure one of the fastest growing areas in aerospace. In many cases, still in the R&D phase, so it's still with a lot of expectations in terms of business that will have to be delivered in the next years. Many different opportunities and very much connected to the Green Deal, because it's obvious that the use of unmanned aerial systems is very, let's say, very good in terms of the use of resources, fuel, fossil fuels, and so on, because you can do the same with much less energy. So in this context, is very good also for this objective, which nowadays we know that, for example, in the EU is really important. So there are really many different disciplines involved in the progress of this sector: artificial intelligence, sensors, avionics, propulsion, because also in this type of airships in the future we'll have to include hydrogen, maybe new fuels still to be seen, which kind of fuels for the future, different materials, new structures, new aerodynamics, new designs. So there are a lot of things going on there. And there are also a lot of uncertainties still to be solved, as I said before. So, and we have to mention, for example, safety issues, very important for air taxis, things like that, because we will jump from a situation where we have just a few unmanned aerial systems now flying to maybe hundreds or thousands of them flying over populated areas, and this is a very important issue in terms of safety. We have to talk about regulations, which are a very important factor for the design of these systems and for the technology involved with them. As I said before, business cases still have to be demonstrated. There are a lot of expectations, but they have to be real in the future, and technological challenges ahead in different fields. So, which is our role in CDTI? As you know, CDTI is the biggest public investor in innovation in Spain, that we manage around 2,000 million euros per year in across different technological fields. Aerospace is, of course, as I said before, one of them. We have a wide range of financial tools to support these R&D projects. We have venture capital, we have loans, we have grants, all type of different tools for the different, let's say, the parts of the projects, or even as they develop in time. So we can adapt our tools to the situation that the projects have as they progress. So traditionally, as I said before, we have been very much involved with the progress of the sector in Spain, and through different lines we have been investing in projects which are valued around 50 to 60 million per year in the last 10, 15 years. So right now, as part of the next generation funds of the European Union, we are currently managing the Aeronautical Technological Program, which we call in Spanish PTA, with 160 million euros in grants for the period 2021-2023 for the aerospace sector. This particular year, we will have a call with 80 million euros for that, and we expect that in total the value of the projects that we expect to fund with this is around 320 million euros, more or less, in the whole period. This year we expect projects valued 160 million, because normally the grant covers 50%, around 50% of the total value of the project. And of course, in this particular program, the unmanned aerial systems and urban air mobility is one of the main technological areas that is included. It was included already in the call that we put last year, and it will be again in the call next year. So we do expect this year a very high number of proposals in all fields, but in particular in this area. So of course this is in preparation, and we will organize several workshops and meetings to explain the call when it is published and it is ready we expect in the next weeks. So I think that more or less this is all I wanted to say for the welcome. I hope I have not been it has not been too long for the organizers. Again, thank you very much for the opportunity to give you this short welcome, and I wish you a very successful workshop today. Thank you.
Okay, before the coffee break, because I know some people, they really need the coffee. Okay, we have this is an honor for us, for all of us here in IMO3D. So Isabel Maestre, she is the Executive Director of the Spanish Aviation Safety and Security Agency here in Spain, and she will introduce the Center of Excellence of Drones. Before introducing her, I also would like to comment that we really appreciate the support of the agency for trying to push the sector and helping us to innovate and create new things. So thank you very much. So very briefly, Isabel, she's the Executive Director of AESA since 2008. She holds an aeronautical engineering degree from the Technical US. Becoming the Executive Director of AESA, and she's a member of the Management Board of EASA and actively participates in international forums like ICAO and IATA. So thank you. Thank you.
Buenos días a todos y mis felicitaciones a las empresas que han organizado este evento y también por invitarme. Good morning for everyone. This is an honor to be here today. And I would like to give only a few messages from the Authority of Spain and what is our philosophy to work in this matter, in drones. Okay, we have AESA is the agency, it's the Aviation Safety and Security Authority in Spain, and we have this participation in the research and development of the aviation, because the future of aviation is facing a lot of things. Of course, UAS, drones, for diverse purposes. Sustainability is very important. The 20th century was, in aviation, the century to improve safety and avoid accidents. But of course, if we want to continue in aviation in the 21st century, we have to be on sustainability aviation. On the other hand, the public opinion we have against of us. And this is very important for us. Of course, the pandemic situation and also cybersecurity. AESA is also the authority in security, not only in safety. And of course, now cybersecurity is key element in the security aspects, in the attacks of the aviation. Aviation is facing new challenges and we need to work with research, development and innovation. And this is why we decided to create Center of Excellence in AESA. I go to explain what is the Center of Excellence, what is the concept. First of all, you could say why the authority is involved in the Center of Excellence in the research and development of aviation issues. There are two reasons. The first reason is safety and security and cybersecurity. All projects, all matters developed in aviation must be under requirements in safety and security. And this is why very important to involve the authority from the beginning, from the first stage. And the second reason is AESA has a position in the aviation system very important because we met with industry, with universities, with final clients, and we can to put together all institutions, companies, and investigators. And this is why we decided to create the Center of Excellence. I go to explain how it works. The first thing is to create a committee of SAGE. This is the think tank Its committee is more or less around 20 to 15 people, no more. And these persons are the most experts, the best experts in this matter. And they don't represent, they are not representation of any companies. They are in the committee because they have the knowledge and experience in this matter. And we have this committee. AESA, in this work, we are the secretariat of the committee. And this committee has university, operators, industries, infrastructure, etc. And they prepare the white paper or the white book and around the research, development, and innovation in this matter. And this committee and this Center of Excellence boost projects make the communication and technical cooperation. Communication is key element also, like today, because if nobody knows or something, doesn't exist. And technical cooperation is also a key element. I go to explain. We have created 3 centers of excellence now. The first was in 2017 for sustainability. You know that is very important in aviation now, the sustainability, and there are a lot of works, a lot of projects on that. In 2018, we decided to create the Center for Drones, UAS. And the last one, the newest, is the Center for Human Factors. We created last year because human factors is key element in aviation. Pilots, one pilot cockpit, or for example, the most automatization in air navigation providers, etc. And human factors is very important, and we have created the last one, Center of Excellence. Additionally, in this Center of Excellence, after to prepare the white paper, in this white paper, we have to identify the future challenges in relation with the current status, in the case of drones, for example, prioritize areas where action should be taken in medium and long term, promote development and research and development within a framework among AESA, University Center of Investigation, stakeholders in the industry, and keep updated the challenges thanks to a think tank where the members are recognized as experts in the specific domain. Additionally, we work, and sometimes with CDTI, for example, in Spain, in order to prepare finance or funds for the new projects. We work together and we put the coordination of everything, of all stakeholders. Additionally to this Center of Excellence, we have and we signed AESA and the FAA, Federal Aviation Administration in the United States, an agreement in order to share the knowledge and experience of the Center of Excellence. For example, in the United States, ASCENT is the Center of Excellence of Sustainability in Aviation, and ASSURE is the Center of Excellence for Drones. We have worked together and we have to share this information, and for example, we are working in sustainability to create SAF fuels from the waste, urban waste. This information and this knowledge proceeds from the ASCENT Center of Excellence, and now we are working in Madrid and also in Canary Island, in Tenerife, and we are creating now the facilities to transform urban waste in fuel for aircraft, kerosene. Well, this is the companies and institutions work in the Center of Excellence in United States, for example, Mitre, NASA, etc., Transport Canada, etc. I go to focus in the Center of Excellence for Drones. The white paper of drones we presented in 2020, and they work in 9 different lines. Now we go to explain more of one of urban air mobility, the development of the urban air mobility. There are a lot of projects now in Spain in this part to check not only the vehicles, all the system infrastructure, like Vertiports. Safety, simulation for safety acceptance, the social acceptance, the equipment for avoiding collision. Security and cybersecurity is key element in drones, as you know. Another kind of line is regulation and certification. We are work in drones. Drones is fast sector. It needs a high speed, and the authorities cannot limit a stopper in the sector. Must be an enabler. And this is why we are working together from the beginning, because the knowledge are not in us. The knowledge is in all together. And we need to work together from the beginning. Social acceptance, noise, vibration, visual impact, privacy, for example, and traffic management, UTM and Airspace. This is part of the lines that we are working. But now we realize that we have to work and to put additional highlights in the Center of Excellence of Drones, and is sustainability. And we have modified the white paper in this matter. Why is necessary the sustainability? And I have listened to AIRBUS and LILIUM mainly in this matter. The studies on drone acoustics, of course, we know. Analysis of the sustainability chain of the drone under circular economic criteria and environmental needs in the management of the airspace. If we are working now, after a lot of decades, in sustainability in the traditional aviation, we have to use the lesson learned and to put from the beginning in the drone sector and to create the technology at the same time, thinking in the circular economy, in the different parts. And also there are a promotion of electrification and miniaturization and automatization in US platform dedicated to work in a natural environment. This is key element because the drones will work, part of the drones, not only in the urban air mobility, part is working now in the natural environment. This is very important, including autonomous system and swarms. And also new specialized solutions focus on environmental management of the use system. And this is our idea. Our philosophy in AESA is to work together with the industry because always we need to work together in order to have a safety aviation and security aviation, including drones, of course. Thank you so very much, and no more.
So thank you, Isabel, for presenting the Center of Excellence of Drones. So I think it's now, after all these interesting talks and inspiring, to network a little bit, to have a coffee. So I think it's in the, we have to go left and then up, okay? So you go out to the left and the stairs up, and you will have a room, a nice room for the coffee break. Okay, thank you.
¿Empiezo? Okay, welcome everyone again. I hope you have enjoyed the coffee break. And just one comment about logistics. In the agenda, you can find a QR code for a survey. We will be very pleased if you can just scan the QR and complete the survey during the morning, please. Thank you very much. And now, let's start with the first round table about airspace integration. As some of you know me, I love to talk, but I will try to be very, very, very quick because we have gathered some of the best guys in Spain about airspace integration, and I want to give the floor to them to explain what they are doing. My name is Enrique Ventas. I'm the UAS R&D manager at ITG, part of IMOF 3D. And the idea of this roundtable is to continue the discussion that we had last year in the same event. We had a discussion just a few weeks after the publication of the U-Space regulation, the basic regulation. And today, what has changed? So for that, we have gathered Ignacio Uriel from AESA, Head of Service of CNS Systems, Daniel García Montavaro, the NAIRE, Head of Drone Business Development Department, Pablo Menéndez Ponte, NTT Data, Project Leader of ATN and UTM, Jorge Chornique, AIRBUS, Project Head of UTN Strategy, Javier Viejo from INDRA, Innovation and Digitalization ATN U-Space Manager, and Enrique Casado from BOEING, Airspace Operational Efficiency and Autonomous Operational Technical Manager. And saying that, I will start with the questions. So the first one is what I said before, is to AESA. Since approval of the U-Space regulation, what has it changed? It's been 1 year since then. Has it met the expectation of everyone? Do you expect any change in the future? Or now, I think, is there more clarity now on how to deploy U-Space?
Thank you very much. Good morning, ladies and gentlemen. It's great to be here and to be in touch with the industry and all these kind of people. Okay, answering your question, the main change is the presence of the regulation itself. It represents a common framework for every stakeholder here in Europe, for NSAs, authorities, industry, operators, and specifically for DB loss operations, defining management services to organize the airspace for safe and efficient traffic. Okay, it's true that this framework, the legal framework, is not enough because I think the maturity of the operational concept and the technical support behind it, it's not yet consolidated. As we have seen, we have under discussion with the industry about, for example, dynamic configuration. So there are concepts still in process. Okay. I think the main challenge is the outcome of the AM&C and GMs carried out by AESA. I think everybody in the room we are waiting forward the result of it, and it's difficult because it's a thin line between strictness and laxity. For us, it would be good to have a checklist. A strict checklist with all the technical requirements for the services, for the service providers. But this is bad for the service providers because maybe they cannot comply with those requirements, and they don't have room for improvements, for technical improvements. So we are anxious to see what's the outcome. In this process, we have found several gaps in this NMC-GEMS related to, well, roughly to the personnel, both operational and technical personnel. We have there are no requirements for them. To the conspicuity, interoperability between UTM services. I think there's a room for development in the future AMC and GM, or in the next steps. As well as we found not enough. How can I say? We would like to have an harmonization, standardization process. I think ASA is working on it, so we will like to know the result on this regard. Because maybe it will be very different for a service or the provider to be certified by us or by another NSA. So it's a challenge for everybody. And I think to wrap up, I think, well, it's a very good first step. I think we have to let the things roll next year. And maybe for the future, we can expect more requirements in order to go towards a more integration of manned and unmanned aviation. So the first step is perfect for this stage, and see what happens next.
Yeah, fully agree with your analysis. Actually, the requirements, we need it. We are asking for it, and we are eager to see what it's going to look like. And for that, I want to do my second question to ENAIRE. Has the regulation met your expectations? We have already listened to AESA. Have it met your expectation? And what do you think? Is something still missing?
Hello. Yes, well, first of all, thank you everyone, and thank you to AIMO for having us here in name of ENAIRE. And the first thing I want to say is that Europe has been very brave because I think that the US space regulatory framework is a totally challenge compared to other ATM or other kind of regulations. So I think it's the positive side, of course, with the support of EUROCONTROL, Sensaria in the teching, and all the industry that are here together. I think it's quite positive, the regulation that has been published. And of course, I have to attach with my colleague from the ministry and National Supervisory Agency has said there are a lot of questions pending, answers pending. In Amsterdam Drone Week very recently, there was a lot of debate with a lot of topics, but the important thing is that we are in the path, we are in the way to do it. We cannot wait for the standard, we cannot wait for the final answer. It's something that we have to follow and to find the answers and to help EASA, to help the European Commission to deploy US space. And that's the reason we are here. Because we cannot wait for the answers. Of course, the MNC and guidance materials will not be complete, but it's normal because there are a lot of things to develop, to analyze, risk assessments in US space, the information to the general public that can be deployed in US space operations, liabilities, because something that the US space regulation said is the US operator is going to address the main responsibility, and it's something that can be so when you have certified system, there's common information service provider or the USP service provider. So this liability is going to be, for instance, a great challenge, and that's, for instance, some examples.
Okay. I think, actually, another time I agree with your analysis, what expectation. I didn't think about the liabilities as a problem, but you're right. It's something that we need to take into account when working on the new regulation. And now for the industry, because we have heard about the National Supervisory Authority, we have heard about one of the companies that will deploy U-Space soon, and the rest of the industry. What steps are you taking to comply with this new regulation to update your research and your product to inline? We can start maybe from left to right. So, AIRBUS, please.
Okay, so I think for us the question is not only how we adapt to the regulation, but how we can support regulation. I mean, the way we see it is that US space per se is not the goal. It is an enabler to ensure that we will have innovative air mobility, that we can put new vehicles and manned ones into the air, and we can provide some services. So we see this as the ultimate goal. There is a need on the society for this innovative air mobility. There is a need for operators to fly, and they cannot fly today, or it is too difficult to fly today. And this is where US space starts to pave the way. And we see the regulation as a first step to set the basis, to start exploring, to start developing solutions. And based on these solutions, we can have an spiral incremental approach in which we start with an initial set of operations that are enabled with the current regulation and the existing services. And based on that, we start to grow and scale into more complex use cases, more complex operations that in the end will arrive to this end goal of having this innovative air mobility.
That's a very good point, actually, to support. It's not to adapt, it's to support and to continue working on the new regulation. Let's see if INDRA has the same approach.
For sure. Once again, I need to agree with Jorge. Is not adapting, is contributing to. Let me say first that our view of the regulation is that for sure we are not seeing the final regulation that we would have. We have a first step. This first step needs to be for sure improved based on the experience we all gather as industry, regulator, deployers, whatever, in the environment we are going to build in the coming months, years. And then we will end up with something much more stable and much more shaped on the future and real needs, for sure. So that's a good step, and let me say that based on that, everybody's looking at Europe right now. That's an important message that we need, and we need to be proud of that because we are part of this, all of us. The world is looking at what Europe is going to do with this US space and additional regulation on drones. We were not at the first position a few years ago, but we are now. So we have a big responsibility, okay, on that, and that's something we need to be proud of, and something we need to consider. So also taking one of your expressions, strictness versus you said facility to adapt or something like that. So one of the things we need to take advantage in order to contribute to the regulation is to enable different ways of deploying it, just to learn in this moment. Also keeping some parameters like enable that the companies can operate in different countries, etc. Okay, having these minimums, we need to learn, to take advantage of the current regulation, to learn and to improve. I think that's one of the things we need to do. And going to the answer to your question, being very brief, what we do in our research and development and our industrialization of the product with regard to regulation, that we embed both the regulatory and the standardization process in the whole research and development life cycle. From the exploratory research, in which we start with the basic concept, up to the digital scale demonstrator, which is, or the very large demonstrator, which is the old name. We embed in all of them both the standardization and regulatory analysis, and we contribute through these packages to the national and European agencies in charge of that, both EUROCONTROL, EASA, AESA in the case of Spain, many other agencies. So that's something that's directly embedded in the whole life cycle of the R&D process.
That's where naturally contribution is key to be able to contribute with all these organizations to keep building the ecosystem. Now the chance for NTT.
Yeah, thank you everyone for being here today. To give you some context, 3 years ago we started a product called AIRBUS. The acronym for automatic do I start again? The acronym for automatic intelligence services for US space. From the beginning, we had a vision and a strong determination to try to anticipate the European regulation, the upcoming European regulation. We are a very dynamic and professional team of software and system engineers who have been up to date, who adapted quickly, and who have been able to steer the product in the direction of maximum likelihood from day zero. That meaning that they've been able to steer the product in the direction of where the European regulation was supposed to be going from our perspective. Today we see that we succeeded in anticipating many of the requirements in 2021, 664, 665 and 666 Commission implementing regulations, which we are now about to be fully compliant with. Also, we were agile to implement most of the recent US-based standards. And at the same time, we developed innovative and sophisticated functionalities for the future of unmanned traffic management. And As you may know, in December 16th of last year, EASA initiated the public consultation of the rulemaking process MPA 2021-14 to develop the acceptable means of compliance and guidance material in support for the EU space regulatory package. Well, a month later, in the January version of our product, we were already allocating tasks to catch up with this NPA. This quick action has allowed us to already support important matters coming out of the NPA, such as the unique definition of the operation geometries. There is one interesting aspect of AIRBUS in relation with its flexibility to adapt to regulations. We have a fully configurable policies engine that enables setting logical and quantitative rules for authorizing operations in US space. This engine operates at the core of the UAS Flight Authorization Service mandated by the US space regulation. It provides AIRBUS with the flexibility to embrace not only regulation changes, regulation upgrades, but also foreign policies in a more economically efficient way. Also, from the testbed perspective, this policies engine becomes a really convenient tool to be used in rule validation through KPI analysis. This is something we will be deploying this year in CIAR, Lugo, in the context of the CDTI project US Sky, developed together with BOEING and ITG.
So that's great. Thank you for the detail. I cannot comment on that. At the end, we are part of AIRBUS too, so it could be useful. So now, last but not least, BOEING, please.
Thanks, everyone. Thanks for inviting me to this event. It's been a pleasure to be part of it. First of all, I wanted to explain or share with you a little bit of the BOEING strategy, if I can do it. I'm happy that the LILIUM representative is not on the on the room now. Just to give you an idea of our interests and especially how the regulation may affect developments and the products we wanted to sell in the future. First of all, BOEING is not developing a platform, is not developing a solution alone. BOEING has two different joint ventures with different companies to develop a platform, one with Kitty Hawk, the name is WISC, and we wanted to develop a fully autonomous air vehicle that will operate in urban air mobility environments. And the second joint venture is called SkyGrid, and basically is focused on developing what is called in the US PSU services, providers of services of US space. It's similar as the USSPs here in Europe. And from our side here in Europe, we wanted to help them to try to adapt the services and the products so that both of them can operate in different regulatory environments, especially in FAA environment, in the EASA environment. I'm really happy that Javier told that in Europe, the regulation is ahead of what is has been happening there in US. And the BOEING company is really aware of it and is really trying to get the most out of these regulations so that we are ready to operate here in Europe. But the idea is that we wanted to, let's say, participate in a number of research projects to try to understand the implication of the different regulatory aspects into the different services and products. But the idea is to move on or transition this knowledge towards towards US and especially to help these regulatory advancement in US. We wanted to play the role kind of interoperability role, saying that if we can demonstrate some capabilities here in Europe and can respond to the EASA regulations in specific topics, maybe with this experience we can help FAA to develop some future regulatory aspects so that we can be well positioned in the two markets, if I can say that way. So from my side, we are in a small we are part of BOEING Research and Technology Europe. We are a very small site as part of the different sites, R&D sites the company has worldwide, and we are trying to participate and move the technology forward to try to demonstrate that it's possible to develop services and products that responds to the EASA regulation here in Europe, but can be transitioned to US.
That's grand.
Thank you.
Thank you very much for different approaches, very similar that companies have been done in the past. So now let's go into the present. Let's go into AESA. What are you doing right now to prepare for the new regulation? What steps are you taking to define USpace, airspaces, and the process to certify USpace service providers?
Well, before that, I would like to say that we should be very proud to be ahead in this regulation process for the first time on this topic. Yeah. Okay, it's true. Okay, I have to say there's different processes between the designation process for USpace airspaces or geographical zones and the certification process for the services, for the service providers. In Spain, the nature of the airspace, neither civil nor military. So, according to the Spanish law, the responsibility on the strategical use of airspace falls on a board called CDTI, with representatives of the Ministry of Defense, Transport, ENAIRE, and us, NSA. And they will lead this process for the designation of the USpace airspace and geographical zones. Below them, there will be a technical board, and for the safety, security, environment, and the other one, I can... Privacy assessment will be led by the single SIS provider. In Spain, we will have this scheme of centralized SIS provider. And the SIS provider is yet to be designated by the Ministry of Transport. For us, the role of NSA, the certification process, it's an administrative process. It lasts roughly 6 months. We would like to be in less time, but it's the standard timeline. It's an iterative process. It's 6 months between the submitting of the candidate to be a service provider until the submission of the certificate. What can I say? We have identified several blocks of requirements according to the AMC, AOGM, and the requirements of the EASA Regulation 664. These are organizational requirements, technical requirements, and economic and performance requirements. Organizational requirements is about management system, manuals, training procedures, so on. Technical requirements, it's about the way they comply with the requirements according to the services. And the economical performance requirements maybe as the more challenging for everybody, because it implies the liabilities and the business plan. Yeah. Which will be this business plan? Nobody knows, because we have no traffic, we have no fares. What will be the first charge by the SIS provider? We don't know yet, and there's a challenge for every. There are questions arising by the service providers, but they don't know how will be their
business model. Yeah.
Yes. There's a final point that those processes of the geographical zones, USpace, aerospace, and the certification process should be at the same pace, because we have the risk next year, if everything, hopefully at January or February, we have several service providers, that we have the risk that they have no USpace to provide the service. There is one requirement in the regulation that if within 6 months they have to provide a service in certain space, so we have to have some space designated. So there's a risk on that. We have to work together with the CDETMA and the Ministry of Transport and all the stakeholders in order to not to have this problem. We have a small answer. We should designate some experimental airspace in order to experiment.
That's a very good idea.
Whether the assessments are good, are enough, are not enough, and extract conclusions.
Actually, that is a very good point, talking about experimental, because my next question is about that. It's about what R&D can do for deploying that, to gather data, to provide this data to authorities. And we have here 4 representatives for some of the main European projects. We have Amulet, USky, Aura, and DeLorean. And my next question is, please tell us about these projects. If at the beginning we start left to right, let's now do right to left. So, Boeing, please, first with USky.
Thank you. As Pablo said before, USky is a project funded by the CDTI here in Spain, although the final customer is the Galician Innovation Agency, GAIN. And the idea of this project is to develop a comprehensive UTM simulator that can be used or can be used for a number of different use cases representing future U-space use cases. So the idea behind of this simulator is to provide capabilities to test and validate different technical solutions, from services to integration of real aircraft, maybe also human in the loop, how humans can interact with future U-space infrastructure. And the main purpose is to have this simulator accessible to everyone, to the community, once the project is finished, or maybe a little bit later, because the focus is to develop up to TRL7. So from TRL7 up to TRL9, until having a real product, we'll need to spend a little bit of effort in coordination with the Galician Innovation Agency. But the idea is, at the end of the day, to have a simulator accessible to the community so that everyone can test and validate different technical solutions and can start understanding how operating in a U.S. space environment means, which is really important, because today we don't really know the limitations, benefits, drawbacks of using a service, for example, for mission planning, or how to manage traffic when a contingency happens. Those kind of things should be tested and validated in a simulation environment so that we can be ready in the real world for any potential issue. So the idea of the USky is to develop a comprehensive UTM simulator that can be used by the community in the future to test and validate solutions. Thank you.
That's perfect. Let's with the next one, with Amulet.
Well, we are project coordinators of Amulet. Amulet is a SAR2 project consortium of 17 companies that has the main objective of defining and achieving an initial validation of high-level CONOPS and use cases by performing test campaigns of UAM flights. These campaigns have the utmost goal of demonstrating the safe integration of UAM in the U.S.-based airspace. This summer, we are going to perform 3 campaigns in 5 different scenarios across Europe. The first of them is taking place in Cranfield, UK, then Enschede, then Amsterdam and Rotterdam, the 3 of them in the Netherlands, and finally in Santiago de Compostela here in Spain. It will be one of the most ambitious validation of the operation of integrated UAM systems that will involve 2 different taxis from 2 suppliers, small UAS, manned helicopters, 4 different UTM platforms, and CNS systems. However, not only will we validate the technical operation of the systems, But we will also scrutinize the sweet spot of the technology by understanding its feasibility, viability, and desirability. Each of the scenarios will be a test bed of different perspectives, the UAM, UTM, and CNS technology, the infrastructure development, the business, the impact in society, the public acceptance, and the process and standards with a special emphasis on airspace structure. In addition to being project coordinators, we are also providing U-Space technology. AIRBUS will have a significant role in 2 of the scenarios. It will provide CISP services in Santiago de Compostela and USSP services in both Santiago and Amsterdam.
That's a great involvement, and from here I invite everyone to keep a look at Amulet, in particular in Santiago de Compostela, because we are from there. In the area, we are the coordinators in ITG, and it will be in September, the demonstration. Now, PJ34 Aura.
PJ34. Well, PJ34 Aura project is a CESAR project. It's a CESAR R&D project. It's the largest ATM U-Space integration research project that I know in the world, in Europe for sure. I don't know others in other bigger projects in the world, so probably it's one of the biggest. And basically, there's something clear. We have segregation in the short term, but the future for sure is an integrated airspace. We don't know how long it will take, but that's the future. I guess more or less everybody is aligned with that. And what PJ34 Aura is doing is working on 2 convergent threads. The first one, looking at the short term, how are going to be able to enable this ATM U-Space communication, even keeping the segregation. You know, the new regulation 664 introduced several concepts around the segregation, like the dynamic airspace reconfiguration for U-Space and many other concepts that at some point are in the boundary of the ATM, let's say.
Yeah.
So PJ34 is looking at this, looking at the different information they need to change in the short term, and is trying to enable this in the short term. And at the same time is working in another thread for the long term, 10, 15 years, trying to understand which will be the limitation of the short-term threat for the future, when we have high densities, high autonomy in the US space, and how the future ATM will be able to handle that.
Yeah.
And this project is divided in several work packages. One of the for the ATM US space in the short-term integration, one of the clusters is based in Spain. We are working with AIRBUS, also with ENAIRE in making some validation exercises to show the findings on the projects. In the solution to, in the same way, we are going to do some exercises also in Spain. I think it's important. We should be proud in Spain because we are leading both the project and the solutions. So we are helping Europe to lead that with solution 2, which is for the future thread, is led by INECO. And solution 1 is led by us, and the project is led by us. So we need to be proud of Spain contributing to this. Let me ask something else, because I got invited by my colleague of BOEING. Some of the conclusions we are arriving to in PJ34 will be also tested in a validation exercise we will do in CAESIUM project. CAESIUM project is the sibling of the USK project, BOEING. Our customer is CDTI with GAIN, the Galician Innovation Agency. And what we are doing at CAESIUM, which is the name of our part of the project, is building a full simulator in which we will have common information server, several USSPs, one specialized in small drones, one specialized in UAM, which will be provided by one of our partners, which is AIRBUS. We also make an interface with ATM systems, and we will make in phase 3 validation exercise with SACTA, with the collaboration of ENAIRE, which is part of the project. And we will have several interfaces to have real and hybrid simulation modes in the environment, with the possibility to simulate different communication performances, terrain, weather. A very interesting project, and it will be very useful for the upcoming research needs that we are going to have in both areas, because also we need to talk on the connection of both projects. So very interesting, and I think we, as a country, we are going to be very useful for Europe in the coming years.
We need to be very proud. At the end, as you can see here, we are running great projects in Spain. We are the coordinator in Northern Europe, so we need to be proud. And finally, Airbus with the LORIAN project, please.
Okay, so I would like to introduce a bit why are we doing the LORIAN before actually explaining the project. And I think when we read about Space in the news, in the web, there is a lot of focus on services, on digital technologies. But there is not so much focus on the infrastructure that we need to support these operations. And we shouldn't forget that in order to get these performance-based operations, we need to have some communication capabilities, some navigation capabilities, and some surveillance capabilities that will support that we can operate safely. It is not just a service, but all this infrastructure that needs to be in place. And this is where the LORIAN gets relevant for us. The LORIAN is a project funded by the GCA agency in Europos, which is focused on validating which are the performance characteristics of the European Global Navigation Satellite Solutions in urban environments. The project is led by PILDO Labs and is focusing to two main use cases. On one side is the people transport in cities, which is the one that we at Airbus are leading. And the other part is focused more on the delivery of small parcels, cargo, which is led by Correos, and the project is really focused into developing these use cases in a real urban environment in Benidorm, in the east of Spain, and validating which are the performance characteristics of the European navigation satellite solutions in conjunction with other technologies to see which are the performance characteristics and if they are good enough or not to sustain urban operations in a safe manner.
That's very good summary. Thank you. And now my last question, after hearing about this project, about technology, demonstrations, simulations, Airspace architecture. Now, ENAIRE, the last question is for you. January 2023 is here. You are planning to be ready for 2023. What are you doing to be there? In 2 minutes, because we are running out of time. Thank you.
Okay, well, as you know, we launched a tender for the platform of Airspace, and we had this last February the final trials of the first phase. The most important thing of this project is that it's the first there was the first European tender that was with the idea to have the European and the regulation architecture, separation of common information service provider and Airspace service provider. It's very important, the answer to when, no, or where. What we are doing is not only deploying the platform, that, well, we are analyzing and starting to check all the certification process. And our strategy, of course, is to become the common information service provider in Spain. And of course, we are collaborating with many regions in Spain. So the idea is not only to deploy systems, but to deploy it and with other Airspace service providers in Spain, and to be a facilitator, the national facilitator to deploy the Airspace in Spain, because the business, as Nacho said, is waiting. Here there are a lot of operators and users, and they are waiting for the facilitation for these operations. So to be brief, that's our objective.
And that's a hard work, because you only have 7-8 months to date.
Yes.
So good luck, but I'm totally sure that you will get it. So thank you all for your honest answer for this interesting conversation. We have listened several points of view. Just to wrap up, we need to be proud of what we are doing. We need to collaborate together. We need to support the regulation. We need to run simulation, do research, do validation like AMULET, P34, USky, DeLorean, Caesium. It's very important to be there to continue ramping up the Spanish ecosystem and to support the European evolution and even more and beyond. There's going to be a reference for the world. So I don't know if we have time for some questions for the public. 5 minutes? Okay, perfect. So you have any question for the panelists or for myself?
Don't be shy.
I have one. I can make another one. Just for example, AESA, is there any USP already start with the certification process in Spain?
We have contacts with ENAIRE.
Okay, that's the main one. That's fine.
Just one.
So you will be the guinea pig trying to certificate the ISPA.
Yes, well, whoever has taken a look to the certification or to the idea of the certification, I think it's going to be a very hard process, and that only air navigation service providers so far are used to have that kind of certification. So I think it's going to be a challenge for other kind of SMEs or companies. So I don't know if there will be some adaptations in the AMNCs, a guidance material, but so far I think that the level is going to be quite high.
We are well experienced certification organization, but this is a brand new paradigm. So we are experienced on these regulations that we all will know, the NSPs for NSPs. So the 373, that it has a previous regulation, that it has another previous regulation. So every organization in Spain do know perfectly those regulations. Right now, it's very difficult and challenging how to expect from those organizations that there won't be only NAITEC probably will be the easiest one. Probably we will face city councils, private companies that know almost nothing about air transport. It will be very interesting.
No, it's a very interesting process. I fully agree. The 373 is a very demanding regulation.
But
so
it's very well known at the same time.
So first and second.
Yeah, I think a very good topic as well, and we'll cover it later on. I see there's going to be likely to be a transformation that initially, perhaps the ANSPs across Europe, with a firewall to their ATM business, will perhaps become the SIS providers. I think SIS providers leave that on one side, perhaps even USSPs. We see that happening in Germany, in Belgium, and UK, and everywhere else. What I think as a community we hope for future is that the entry barriers for private providers or budding providers for USSPs will hopefully become lower in future once we have more experience, we have more standard scenarios and better knowledge, so that new private companies can also come in to become USSPs, and therefore to provide a competitive landscape for Europe as well. But I think this is a transformation, and I'm really happy that the NSPs are leading right now to at least kick it off. Because unless we kick it off, we learn from it, we will never start. So I think there's going to be an evolution.
They need to pioneer.
Yes, they need to pioneer.
No, for me, I just wanted to elaborate on the same argument, but with a different angle. And is that, the regulation doesn't say it's mandatory to have a CISP. It is a decision. And in case there is not CISP, those functions need to be integrated into the USSP. They need to have something that emulates the functioning of a CISP. If we say that the certification for the CISP limited to ANSPs because the experience, because that, de facto we are saying that only the ANSPs can become USSPs. if we use these arguments. So I think on that line, it's important what Munish said, that if we really want to have an open marketplace, which was the intent behind, we need to ensure that this doesn't become an entry barrier, but just the vehicle will have to ensure safety in the best manner.
Yeah, if not, we have same situation and we need to regulate again and create another full ATN regulation ecosystem by itself. So thank you. I think we okay.
No, I will go there. So anyway, I have a question because I'm not for sure this user that you are talking about. Do you expect any target goal or target date where we can really use and provide all these servers or test bed or a kind of sandbox in Spain? Forget. What do you expect? I'm curious because I will present in a few minutes my experience. So what do you expect I can use as company the US base?
Not as company, maybe personal view. I think that it's going to be, well, a challenge. And what I expect is to use the demanding of different regions asking for use cases that they are already developing, and to start with that use cases, to use the sandbox law, the experimental sandbox law, if we...
Discuss later. I invite all of you.
Yes, yes.
Because we have one.
So it will be very interesting, that outcome. So the idea is that maybe we'll have something, but we have start to a very controlled zones or sandbox with risk, limited risk. So it's going to be a step by step. So
Do you have any plan or any
our plan is to attach to the planning of the next January, although we know that it's very difficult to commit it, but that is target it's a short target, and we are working on that.
One more.
If I may add something to your question, to the answer, not talking about Spain, but generally. So my view, regulation is an enabler, but it's not a solution at the moment. So it's going to be difficult that on January 26th is the date, right, or 23rd, we are going to see US base everywhere in Europe now. It's not going to happen, being honest. But it will enable us to, probably at the beginning in very localized areas, to start things that we couldn't do before. So if we look at the regulation and the new situation like that, we have a lot of chances. We will have a lot of chances in January that we are not having today. And in the case of Spain, there are a lot of homework that are already done, or that are being done at the moment. Not everything, no, not everything. Nobody has everything done, as I said, but we are well positioned, I guess. It's my personal opinion. Yep. So that's my view. So if you look at this, we can do a lot of things in the future.
Professor, thank you very much. And Don.
A ver, espera.
Este. Voy a dejarle un momentito que se quiten las cositas. Nada, de aquí puede ver. Sí. Yo creo que eso, hay que buscar unos casos de uso. Let's continue. So after this very interesting roundtable, I think it was very fruitful and a lot of very interesting conversations. So now let's welcome Marta Cejuela. She's the safety manager and head of Airworthiness at FlyingBasket. And she has a strong background in initial and continuous awarenesses, safety risk management, and regulatory compliance in civil and defense aviation. Worldwide experience, working previously in Airbus Defense and Space, Mitsubishi Aircraft Corporation, and Air Nostrum Iberia Regional. She's leading since October 2021 EUROCONTROL Working Group 105 Subgroup 4 activity and participating in the ASA Initial Awareness Working Group from RMT 0230. So thank you, Marta, and I'm pretty sure we're going to see very interesting things, real things now happening. Thank you.
So, tampoco sé hablar muy bien español, gracias. So thank you for inviting us. For us, it's very have this honor to be here because practically 1.5 years before we were playing in a garage, so nobody knows us. So we are very proud. So I don't know if you can start to the presentation. Oh, okay. So the journey of FlyingBasket started in 2015 when two brothers, the brother Matthias and Moritz in their area, were hiking and came with the idea to develop a drone to transport goods and delivery in the center of the mountain because they were hiking and then noticed a helicopter. Said, hey, I want to do it, this one with a drone. Why not? And they started to investigate it and discovered that in the market does not exist this cargo drone. So they decided to start and develop. And for sure the idea was to doesn't justify the helicopter because it's true that maybe we can justify it in some risky operation. But the idea was also in to complement, okay, the helicopter's operation. But for sure, they started started this research and development prototype until 2019, more or less, when they come up with this research and development and do the first flight test. After that, this was not possible if this team, we changed, more or less, we are growing up now, with passionate, very younger, the average is 25, continued until we are today. So for me, it's my personal point of view, and I was discussing yesterday night, that the human capital is the most important today in these new technologies, because you can have IP or whatever, but to retain the talent is, I think, the key today. Oh, sorry, yes, sorry. Sorry, thanks. So for sure we have a team that's a prototype that became true. And we have now the product, okay? This product is, empty weight is 70 kilos. We can carry up to 100 kilos. And we fully electrical driven. And we use swappable lithium-ion batteries. The flight time depends on for sure, the load. If we carry heavy loads, we have less time for sure that if we carry less. And we cannot certify it, but we qualify more or less, so we test it, is the best word. The drone up to 3,000 meters, because for sure our site is in the Alps in Italy. And I want to introduce, I don't know if it works or not, my two brother model would not be there, so
we are the only ones authorized
we cannot listen.
So drone of the FPV size. Our cargo drones have already performed many missions in sparsely populated areas to prove their versatility, such as the sectors of energy, telecom and reforestation. So we manage this by getting authorizations in different EU countries by collaborating with the relevant authorities there.
Yes? It's in the cross border. So you can continue this because the video is so long, so the sound. Is the site of the company in the Alps.
With the new authorizations that we obtained this year, we have already been able to start commercial operations with a few selected big corporations in both the telecom and energy sector. We have the possibility to already start scaling up with them internationally, and we will be able then to also expand to more industries in the future. There are a lot of different methods to transport things today, but they all have either very strong limitations or are very expensive. If you take the helicopter as an example, it's a very flexible means of transport, but it's extremely expensive and therefore just available to few selected industries. What we are really doing here in FlyingBasket is creating a new aviation solution, a drone transport solution, in order to make this aerial transport accessible to a lot of industries where it hasn't been available before, and therefore give a lot more flexibility for a still low price. We have seen our operations grow enormously in this year after the European regulation came into force. What we would like to see and also try to participate as a company in the industry standardization bodies and in the workshops that EASA is organizing is really that this regulation becomes more and more mature, so that this new emergent industry can really grow in the next years.
All of this is happening because of our team, a group of motivated individuals that come together to shape our mission and vision into reality. A great mix of cultures, professional and educational backgrounds that reflect our company values. This is our starting point to become a leading force in the industry in Europe and the rest of the world to provide technologies and services that will shape a better future.
Video. Okay. So as you can see in the videos before, we were 1 year ago, we obtained the cross-border operation. Thank you for sure of the maturity because enter it into force, the 947 2019. And this was the first operation for sure in other countries. As you know, the US operator should be registering the country, the member state, in our case is Italy. At this moment, it's true that an Article 13 exists, but not the maturity of the regulation, I mean, related to means of compliance or guidance material. So thanks to this experience, not only with LVA, with Germans, with Austro Control, was possible to create a working group with the authorities and establish what is needed. Practically one month ago, they published one ED decision where included this means of compliance thanks of our experience doing cross-border. Because practically, as we are in the center of Europe, in the heart, we can provide service today to Italy, Switzerland, Austria, Germany. Also, we were in Denmark, because we are there in the core of Europe. You see the videos. This was the first operation in cross-border outside of our member state. This was the second one, but we continued with this kind of work, this application, the installation, for example, of 5G antenna, not only in sparsely populated areas, for sure, that helicopter could do for sure. Also, as you can use a common crown in an urban area. As I explained you before, this means of compliance we created with the AESA and supporting what is the application form to be harmonized between the NAAs, because this is always a problem, no? Every member state could understand or interpret it sometimes, the material, no? the regulation, and this is the challenge today too. In this case, we also provide service for maintenance, the air generator. In this case, was in Denmark. As for example, in case of Germany and Austria, take 2 months. Thanks to the means of compliance, takes one week to be approved to fly in Denmark. So you can be the time frame, how the regulation, for sure, could support the scaling up the business. I will start because today we are here discussing the advanced air mobility. So today we performing practically in urban areas, in this case it's in Switzerland, with our customer Cavalex that trusts in us, and we sign a contract. This was in Olten, in industrial area. We can discuss and debate after. It's beyond visual line of sight with airspace observer over sparsely populated areas. You can set, hey, you are in urban, there are a density of population, how we can set in this way. In this case, the operation was granted under the PDRA-01, the equivalent in Switzerland, because Switzerland today still is outside of Europe, but the regulation practically is the same. You can see several pictures. The advantage for sure, you can not control the area, but it's the same like a a crown. No, when you go to the street and I see a crown in the middle of in an area, I never go and said, hey, I want to go and go inside. So the authorities consider that in the area that we are operating is sparsely populated because nobody is there and are under the shelter. So we always tried to operate in not core time. I mean, if you fly early in the morning and there is no population, so there is no risk. The risk is low. In this case, this is the area of Olten that you see here. This is the area, as you can see, is industrial area. But for sure, as I explained there, the urban area was, in this case, 460 meters, more or less. We use a rope of 18 meters. We carry mobile antennas and material and radio equipment to install the 5G. In total, we carry 1,000 kilos for sure with different fly, not at the moment because we only can carry up to 100 kilos. And we have a contingency area, and you can see all of there. And I like Switzerland because they always have a very clear definition what sparsely populated means. And they have and recommend you to use this Swiss topo, as you can see, where is populated and what is the density of population. So there is a sort that you can use when you perform the SORA, because today we have this debate with EASA, what is sparsely populated, what is not, is in Charus, what means adjacent area, what is not, this kind of discussion. But in Switzerland it's very clear. You use Swiss topo if you have more than 11 inhabitant house, is not sparsely populated. You use this one, and perfectly you can use. In our case, as you see in the area that we did it, was sparsely populated. And in the risk class, it was class G. For sure, there were not airport, not airfield, and was very quite close and glider airport that we coordinate with him, and we notify that we will fly in there. So it was no problem. We coordinate, and still under discussion the adjacent areas. But as today there is no just a consultation paper related to the step 9. So still is there. We declare that we have a flight termination system, and that's all. So the step 9 is over there. For example, yesterday I could not have the video. I saw some of you, but if you wanted to show it, I can show later and during the last time. In the area of St. Gallen, yesterday we also installed a new 5G antenna. As you can see, for sure, is all around the area is populated area, so it's urban. But the operational volume, except one piece of the road, we didn't cut the road, so the car continued to go there. But we argued that the time of exposure was very short time because our flights are less than 5 minutes, as you can see it in the video. Is go to the top of a roof and go back. So, but in this case, we could not, because as you see, this is really populated area. In one part of the ground buffer, in the red area, there is the railway track and also a station, train station. So we cannot argue that this is not populated. This is could be not especially populated. So finally, when we were discussing with the customer, said we will not ask to the authorities to perform an operation there because this is not especially populated. We cannot cut the station. Okay, and this is another one that will occur in December. We will plan also to do in June now another 2 fly. It's with a project with our partner Leonardo. The project is called Sumeri Moderni with the Postal Italiana. And in the Torino city, that they try also to set down their sandbox, but still the sandbox for air is under discussion, like here. But they are in Italy one law for this kind of, to have this protocol to allow to create this sandbox for US space in the future, and also for drones or for use case. So in this case, we follow the European regulation for sure. We use, as you can see, we started in the industrial area, but we flow over the river. So the river is a sparsely populated area. So this is the reason, and again, but you can have a failure and you go outside of your operational volume and you are in the city of Torino. For sure, it's populated area. How we performed the operation was with two kind of drone. Was that you see in the videos in the slim payload, but also we modify because the partner, Poste Italiana, wanted a cargo bus, so we created the other cargo compartment, and we carry 25 kilos from one logistics center to the other. So in total was, I think you can see the video. Yeah. This flight was the first time that a drone was integrated under controlled airspace. This is the reason I asked it before related to the US space. As you can see, 20% of more or less of the operational volume was in the industrial area. We carry 27 kilos, and in total was 7 kilometers, but because it was go and back. So was the one round trip was 3.9 kilometers. As I explained you, the 80% of the operational volume was over a sparsely populated area because it was the river, but the rest was not. Was in an industrial area. As you can see in the video, was a chemistry building facilities, but this was in the adjacent area, not in the operational volume, but still the risk is there, it's true. So in case of the risk, as we integrated with fringe part of the Torino Castle, this is the airport, we coordinated with them. And also we have 2 areas that was not allowed to fly drones using the ENAIRE drones application. So in this case of Benaria Real, we need to coordinate with the military airspace controller. And in case of the Torino Città, I'm not sure why, but the prefecture has, like, you cannot fly because it's the Torino city center. And that doesn't allow, so we need to coordinate with them because part of the flight cover this case. We obtain, because it's true, as was controlled airspace, was the risk class was ARCD. So the way to reduce their risk was to ask for a temporary segregated aerospace, but was by a slot, because we were coordinated with the airport. So this was the chaos. We have no unused space. The server provider was for manned aircraft. And we obtained it, as you can read there, was a slot of 1 hour, 1 hour and a half, 30 minutes sometime. We need to communicate with them because we use radio communication, air radio communication. We have the course for sure, with our operation team. And also by phone, the DFly, that is the, like ENAIRE drones, coordinate with us because it's, I think, a joint venture, DFly between ENAIRE, and Leonardo, I think. I'm not sure, no? Yeah? Yes, it's Cristiano. So during 2 days, we performed this 11 successful demonstration. Some of them for sure was to test that all was okay, and the 3 was the long one. The lesson learned that I want to share with you, and I finish with the US provider in the future. This is very good to have this kind of use case in the urban area because allow you to give our lesson learned or the experience was for sure to mature the regulation in advanced air mobility context. The problem was as they give 10-30 minutes, it's very tight to coordinate everything. We have Airspace Observer, big teams, coordinated everything in 2 locations. So we recommend that maybe in the future when we will have the corridor, we have the full-time slots. So if you need to coordinate a start, not a start, because or fly at very tight, I mean 10 minutes, but in case on another US operator that use wind fixed and the fly is longer than us, it's so complicated to coordinate and do daily this kind of operation. In this case was a proof of concept, but daily we need to improve. I hope with the US space become true. As I explained, we need to find before every time a slot, but was not very good. We need to wait a long time until we coordinate by phone, the quiet voice, because sometimes could be a problem. So recommendation, US space. And another thing was we signed an operation letter with the airport. And the safe altitude that they recommend to us in case of a failure, we never perform a very good safety assessment related to with the service provider, that in case we have a failure or performance need to be considered, and how is the time to be hovering in case that we have a failure, we communicate with them, unmanned aircraft, an helicopter could appear in our TSA because could occur, and we have no time to communicate and was not considered. And we strongly recommend to the airport to also do this kind of safety risk assessment, more dedicated, depend on the platform, because every platform has their own performance. So I think that should be considered when we put the mitigation to control manned and unmanned aircraft. And this is all. So practically our mission is to be the world leader in cargo drone for safety critical mission. We are really committed with the safety. So I encourage, 1 year ago I was in UNBEX fair in Galicia, presented that we crash a drone. We are happy that we crash a drone because it's the lesson learned. I think that we need between the industry today to say why this occurred. And encourage all of you when something happens, never be high and never share. Because if you don't crash a drone, because the providence is there, is because you have only a mock-up is there, because the accident occurred, the risk zero is not possible. So the best is to have a proactive attitude and things, if you share, also it's not mandatory. We share it with the AESA, with ENAC, with all, or lesson learned what's occurred, and later we obtain all this kind of operations. So I think that they really trust in us. Invite, as I explained it today, I'm co-leading the means of guidance for means of compliance. Some face here also support me with this task. And I think it's so important that all of us, all the stakeholders, work together with the AESA to mature the regulation to become true this scale-up business. So thanks for your attendance, and if you have any question.
Any question?
Oh, Daniel.
Hello, thank you for everything. This is Claudia from Net2Fly. I have a question in terms, I don't know if it really applies you because you have the sandbox, right?
No, no, I have no sandbox.
No,
so
not
the
the
sandbox does not exist. It's like in Spain.
Okay.
So
okay.
today, the sandbox, in Italy, there are a law. In Spain, it's a protocol, a proyecto, a project. In Italy, have the law Sperimentazione Italia. They have for the rest of mobility in Turin, but ENAC still are under discussion if they apply or not the sandbox, okay? Just to clarify.
Okay.
So I follow the current regulation.
Let's see if you can answer. I'm curious about, I guess that this has been controlled by ground station, right?
Yeah.
The person that was doing that, what kind of license need for be able to fly over 25 kilos drone, which is something that is like something sensible right now, no? It's still being defined if it is going to be a pilot. So we are able to scale this business. We need to know what kind of licensing we need, no?
Okay, in the current regulation and the means of compliance, the last ED decision explained what is the requirement for a specific category over 25 kilos, I mean, outside of the standard scenario. So today, in a specific category, for low risk and medium risk, is from SAIL 1 to SAIL 4, is the responsibility, accountability is under the US operator. For sure, in my operational manual, I claim that the pilot for sure at least has the open category and the standard scenario. But it's true that today the standard scenarios, we are pioneer in Spain, so we are proud again. The European standard scenario was a copy and paste from the Spanish one. And at least this kind of certification we can set, pilots. And then we train. But in the high risk specific category, as TC, the type certificate, become mandatory, the Part 21, in the internal discussion with the rulemaking task of 0230, we are preparing a kind of pilot certificate as for the the VTOL. So will be a specific pilot certificate also for continuing airworthiness, the same for maintenance, Part 66, the same. So below, below SAIL 4 is we need to train our team. It's under our responsibility.
And did you need? It was required to use like a transponder.
I cannot hear you.
Did you require to use a transponder or parachute or all those requirements?
Okay.
That?
So today, for example, in I think in 1 week, we modify and hit the platform. We integrate now just a receiver of ADS-B, but just a receiver today. Our intention for sure is to not just a receiver, but still we don't rely on. We continue to use the detect and avoid. We use the airspace observer and these kind of things. So,
thank you.
The maturity. Question. Was Daniel first? No, I'm afraid she's so technical. I'm the worthiness.
In your presentation, you said that the flight was collaborating in Torino. My question is, did you integrate in some way the position of the drones in the system that has the flight in some way with some traffic information
yet.
Or not?
The intention I was discussing in Amsterdam with Cristiano, if you know him, maybe to try it. This is our intention, and I invite also in Spain, when you have the US case, we camp here, very happy.
So thank you, Marta. I enjoyed your presentation. Question about autonomy. That's mean navigation, GNS denied environment, accuracy, these kind of things. Autonomy.
Autonomy related, but do you mean the autonomy of the budget?
If they are autonomous.
No. Today, no. We only have automatic operation, and the next week we will try also to land and take off automatically.
But that means that you cannot provide a list of waypoint or a target?
No, yes, we did, but for me this is not autonomous. It's automatic.
No, autonomous for me is navigation engine.
Yes, we use it. No, this is
the mission for the delivery, not the target for the delivery. You also have
Yes. Yes, the accuracy today is good. Yes, and we always do automatically.
Half a meter, 20 centimeters?
Seriously, I don't know because I don't know this detail. But if you want, I can ask to my team.
No, the last question is about the wind.
The?
Wind. Windy conditions.
The windy condition. Today, the limitation, I think that we have 5 meters per second. I think today.
Because for the mountain regions.
The problem was not the platform itself. As we carry with the sling, sometimes, you know, the pendular movement, I'm the safety manager. So I limited them several times because I don't, sometimes, you know, the oscillation could create unsafe condition. So it's still... Okay, don't worry, we have a business pending. Win to win.
Okay. So I would like to ask, if possible, a bit about the business aspects of Airspace from an operator. So let me explain. When everybody says that the airspace will be an open marketplace, that means that the operators will have to pay to access the airspace. So do you have some thoughts already in your organization about which is the right order of magnitude you will be willing to pay to do your operations? Because you will have this scalability, you will have this potential to fly more, but at which cost? Do you have some ideas on that?
Not yet, but I know I was discussing with your colleagues in council. So not yet. It's part of my business, but I have no time. As you could see, we are 25 people. Okay, so people that know me here is sometimes I have no time, you know, or I need more time per day, or I present to doctor, you choose. No, but it's a very good question. And there were another question.
Yeah. Hi, Marta. Nice presentation. Congratulations how you are moving forward on that. I got a question. You present the scenario in Switzerland, if I remember, Saint-Gallen. You were with FOCA. And you mentioned, well, probably you're mostly operating in airspace. So how you manage to be separated with emergencies for helicopter? Because they are quite active there. And do you have in place any particular procedure to coordinate with them?
No, the only today we have is like the required in the regulation that for a risk class in the, no, strategic in the, I forget now. The strategic, the next is the tactical. Tactical. The tactical one is like we have always airspace observer, so you always could see and avoid. So this is today, for sure. Step by step, with the investment come. This is the key and important. I'm very proud because when I see all of you here, Airbus is my ex-company, Boeing. I managed operational planning in the past, and when I compare the budget that I have when I had, so this is the reason, step by step.
Thank you.
Thank you.
Okay, so today I think we have been working with a big overview at the beginning with the future, the aerial taxis, the big company, aeronautical company in Europe, the newcomers, then this very interesting roundtable about the integration to space, the reality, no? What is happening now, is very important. This is happening now. There are people that they are making money, and there is a business, so this is also very important. It's not just R&D, it's starting people to make business. And now we would like to welcome Munish Khurana, Senior Manager Business Development and EUROCONTROL. So hopefully he will provide a broad overview, you know, what is happening. So Munish, in the previous role, he defined and implemented customer-centric strategy for NASPs to enhance capacity, efficiency, and safety of its operation. Munish holds a research degree in software engineering from Nottingham University, UK, and a global executive MBA from Rotterdam School of Management. He represents EUROCONTROL in the European network of Airspace stakeholders in partnership with DG Move, EASA, and CESAR joint undertaking. So, thank you, Munish. Welcome.
Thank you and good afternoon. Honored to be here like everybody else. I do have one extra challenge compared to all my predecessors, and that is that I'm the only person between this presentation and your lunch. So I know what will happen if I exceed my time limit. So what I'm going to do is, although I have a presentation which is rather long, but I'll leave that because you're going to send it to everyone anyway. But I will skip a few slides because I really want you and also me to have a good lunch on time. So 3 things that I'd like to talk about today, really. First of all, to give you all a highlight of what EUROCONTROL actually does, because some of you may or may not know what we do. Secondly, I'd like to then talk about how we at EUROCONTROL are supporting the advanced air mobility, the 6 or 7 things that we're doing. And lastly, I'd like to highlight, perhaps put a little bit more meat and a different context to what my colleagues and predecessors did on the challenges we face and what are we doing about addressing those challenges, and perhaps finishing off very quickly with a strategy that European Commission is currently defining. It's called the EU Drone Strategy 2.0, where we are part of it, just to give you a flavor for what to expect in future. Okay, so let's kick it off. Right, first of all, well, without going into too much detail really, that monitor isn't working. Is that, or is it not switched on? Okay, right, never mind. Right, it's all right, I'll just memorize the next 40 slides, that's all right. So, first of all, a quick overview of what the European aviation market looks like. This is how many people, how many airports we have, the geographical area. So the crux is very diverse, very spread out, lots of challenges. Needless to say, we've all suffered due to the pandemic. Needless to say that we have all suffered due to the pandemic, and you can see the figures over there. They don't read very well, but unfortunately, we've all of us have suffered as a result of that. And the reason why I'm showing you this is because EUROCONTROL has had a role to play to come out of this pandemic with preparing on how to recover, how the aviation market should recover. And we are hopefully seeing a recovery right now as such. Now, we at EUROCONTROL, of course, we are headquarters in Brussels, and we have an operational center, an en route operational center in Maastricht, R&D center or research and innovation center in south of Paris in Bretigny, and a learning center in Luxembourg. Our history, we are a few years old, as you can see, and therefore, as a result of that, working with all of you, particularly with our colleagues, and no doubt in the AICIA and the ENAIRE and many of you, we've expanded. So today we have 41 member states, but we also have 2 associated members as Israel and Morocco that we provide services to. We are broken down into these functional groups, and basically I would say the most visible part of EUROCONTROL is network management, and I'll talk a little bit about what that does. The other part looks after the strategic issues and the more business development issues, which is where I'm belonged in. That's the Directorate of European Civil Military Aviation. We also then have a function where we gather all the route charges from airlines and then send them back over to the member states across our Europe, HR, and no doubt an en route center. So effectively, this is, in a nutshell, what we do is we manage the network of air traffic across Europe. And you can see some in pre-COVID times in 2019, we managed up to that many flights. A very, very important part of our role is to coordinate between the civilian aviation and the military aviation. And we play that key role on behalf of all the member states, of which Spain is a key member state of ours, no doubt. And therefore, working with European defense agencies, NATO, and individual national military associations. Someone highlighted in the previous presentations as well, I think it was the honorary lady from AICIA, I think the director, and she said how important sustainability is. And she said that the previous century was about safety. We still are about safety. That's really what we do at Eurocontrol. We're in the business of safety of aviation. But sustainability, environment, reducing carbon footprint has become one of the cornerstones of the European Union's policy, and therefore we are playing a huge role in that as well. I mentioned that we gather the route charges from aviation to airline flights, and then we spread them back over to the member states. So a little bit about, I would say, probably the most visible part of Eurocontrol, that's Network Manager. We are spread across 43 states. And for those of you who don't know Eurocontrol and what Network Manager does, in simple terms, if a flight takes off from one airport and lands at the other airport, the bit in the middle, when it's flying over it, where there are so many flights flying, crossing each other, that traffic, that flow of traffic has to be managed, because if it's not managed, then either the flights can't take off because there's unsafe territory in the air, or they need to land very quickly. And therefore, we manage the flow of traffic on behalf of all our European member states. Gives you a little bit about the trajectory. That's what I was talking about, of what my colleagues in the flow management do from the time that it takes off to the time it lands. We look after the safety hazards. We look after the operational hazards. Some of you may know that radio frequencies are a scarce resource everywhere in the world, particularly here, no doubt. We manage the radio frequencies because we need those for our CNS equipment, the communication part of the equipment as such. We manage the airspace configuration or reconfiguration. So, for instance, keeping up with solidarity with our Ukrainian friends and colleagues with what's going on these days, we've had to change the traffic going through the Russian and Ukrainian airspace to go around it if you were to go to various countries. That management of the airspace is also managed from the network management part of it. So very important part, again, down to safety. And we do a lot of operational planning for future, which helps our member states, no doubt, and stuff. Very proud to be in Spain to talk about this, because INDRA was awarded the contract to modernize our equipment, to prepare it for the next generation of operations, which are going to be more digital, which will then hopefully be able to manage bigger volumes of traffic, more complexity of traffic. And therefore, this project has been kicked off already, and we will have a new network operations center with the deadline that at least the operation starts in between 2023 and 24. And teams of our colleagues and friends from INDRA are now based in Brussels, working on a daily basis, and a lot of work has already started. So very proud to be here and proud to be talking to you guys in Spain. Maastricht UAC is an en route operational center, which is above a certain altitude. And we've completed 50 years of that this year. We are spread over the 4 countries that manage this are Netherlands, Luxembourg, Belgium, and Northwest Germany. And it crosses the borders across those countries. You can see the number of traffic, the amount of traffic we control, and these are figures from the pre-COVID times itself. So you can see some areas in that airspace that are very congested, and that's where the challenges are. Very important, about a year ago, we have created an innovation hub in Bretigny, south of Paris. And in there, which used to be research and development, is now research and innovation. The key difference there being we still do a lot of work. As you know, Eurocontrol is 1/3 founder of the CESAR program. itself, so we still do a lot of R&D projects from there. But we have recently established an agile innovation activity in the innovation hub there. What that means is for ANSPs, airports, for airlines and OEMs and so on and so forth, you can join in to do 6-month cycles of development work to solve your specific problems, such as runway incursion. If you have any problems at certain airports with runway incursions, a group have been working together to try and identify specific objectives to solve. So CESAR can take 2 to 3 years to bring out solutions, but with this new agile innovation hub, we can actually bring out solutions in 6 months. But that's really working with you people on objectives defined collectively by all of us together, and realistically something that gets done within the 6 months. And the whole idea is that what comes out of this can either be fed into the CESAR program, or it can actually act as a starting point for CESAR projects in the future. So the idea is to do this with agility. I think enough said about this already, that we gather the route charges from airlines and then we disperse them to the various member states. In Luxembourg, we have a fantastic facility where you can seek training classes on all aspects related to not just the ATM, but also the U-Space UTM as well. And we have online courses as well as courses over there. As I mentioned, we play a key role in coordinating between civil and military sectors. Sorry if I have really gone through very quickly, but I don't want us to be here minutes after 2 o'clock, because that's lunchtime. Sustainability is key for us, and we are playing a role trying to align with the smart and sustainable strategy of European Commission, where we're trying to come up with tools and methodologies to measure the carbon footprint and also to try and reduce it using, by doing analyses, by gathering the right data, studying it and feeding it back to the member states. We're also working heavily on the sustainable fuels, the SAF aspect that someone mentioned earlier on as well, and aligned with the European Commission's smart and sustainable mobility strategy. We're trying to feed that more and more into think papers, so to try and create if you like, a brainstorming sessions where people actually come together and act as a catalyst. That's what we like to do, is to act as a catalyst. And at the same time, you can go to our website of Eurocontrol and you will see on a daily basis the current state of aviation in Europe. We publish these reports regularly. Some are daily, some are weekly, and others are monthly. They're insightful analyses. Right, so let's go down to the second item. So a lot of our colleagues and friends have talked about the advanced air mobility, the challenges, and where are we and where we're heading. At Eurocontrol, we are focusing on about 7 to 8 activities that I'm going to talk about now. First and foremost, of course, is our research and innovation. We are involved in a number of projects, and some of our partners are sitting in this room, no doubt. In the research and innovation, we are led by a flagship project that we have at Chorus XCM, which is basically developing a concept of operation for urban air mobility, similar to what AMU led, which you heard a little bit earlier. Likewise, we will also be doing some demonstrations this summer. In addition to that, you can look at the list, and no doubt you can also go and take a look at our website to learn more about it. But you will appreciate, looking at these projects, that we are trying to work on the key aspects that we've spoken today, U-Space and ATM integration. We're looking at understanding the interface between them. We're looking at the safety dimension of the safety methodologies going forward. And we're also looking at the demand capacity optimization and so on and so forth. So very active there. In addition to actually participating in the projects, we're also doing another activity behind the scenes with the CESAR program. And that is where these CESAR projects start and they deliver outcomes, we're working with them to ensure that the outcomes actually consolidate in a way that one feeds into the other. And so that all these projects, as they advance through their life cycles, they feed into the right areas so we can accelerate the R&D activity. And therefore, you will see here connections between the projects where we're trying to make sure that they are logical. We are heavily involved in the regulation development, both at European level as well as at ICAO level. A lot of our previous presenters have already spoken a lot about it. My colleagues, myself, they have been involved in the original regulatory development, but also these are the 4 work packages where we led the development of acceptable means of compliance and the guidance material. I think it's fair to say, and it was highlighted earlier as well, that not everything is fully done. There is certainly room for improvement, but equally right to say that we are in an evolutionary development regime, as opposed to conventional aviation, where a lot of the things were done, and we've learned a lot over the years. The path that we as a community have taken for urban air mobility and use-based development is that we are trying to do it much quicker than what conventional aviation did. We can't wait for that long as such. So therefore, it has to be evolutionary. In addition to that, my colleagues are members of the ICAO AIRBUS panel, certainly co-repertoire for the command and control, the C2 link panel, and we try to influence the ICAO practices, bringing in European ways into the ICAO way of doing things, and to make sure that our member states' interests are secured. In addition, there is a need, but there's already a lot of work going on. I think, Martha, you also pointed out in your presentation for standardization, whether it's EUROC, EU SCG, or other even ASTM type of standards that are outside Europe as well. We're heavily involved in those, no doubt, as well as with the IATA guys to try and identify best practices and standards to move forward. I'd like to spend a little bit of time on this slide. That's the reason why I moved very quickly in the previous ones, because I think it's important, and in that panel discussion you learned that yes, the regulations are out, and yes, they have many gaps. I think Javier from INDRA highlighted, and so did Jorge from AIRBUS, is not every member state's going to be ready by January next year, which is the deadline to have the use-based regulation implemented. And at EUROCONTROL, part of our work is actually to support each member state on their specific needs. And I can tell you that we are inundated by requests from our member states, some member states, to help them in implementing these use-based regulations. I think it's fair to say that in Europe, we are not all harmonized or working on one pace. There are those countries, including Spain, that I'd like to think are more advanced, including yourselves, no doubt, and you highlighted that in your previous panel discussion. But there are other countries that are far behind, a lot far behind. They haven't engaged as much as you guys have done and other advanced countries have done. And I think it would be fair to say that I'd be very surprised if they can manage to have compliance completed by January next year. But they're all working. They're all trying to do their best. What we are trying to do is we are trying to help them in a number of ways. One of which is to conduct airspace assessments. Now, the use-based regulation, 664, as you know, requires competent authority to designate a use-based airspace, but also at the same time to have an assessment done of the airspace to understand what the blockages are today, what's available today in terms of use of the airspace for drone operations, and then to use that outcome of that airspace to see what your goals are. If Spain wants to conduct UAM operations, let's say air taxi operations to transport humans in a busy environment like Madrid, that's one very specific goal. Put that on a side. Versus doing surveys or maintenance activities or inspections, perhaps of pipelines in rural areas, or to do parcel deliveries, as Martha highlighted, perhaps in remote areas. That's another objective. Now, once you know what your airspace looks like, having done the assessment, you will be in a position to figure out what's possible and what's not possible. And then it's going to be a decision for each member state that if they want to ensure that they want air taxi operations in urban environment, they will have to reorganize the airspace. It'll have to be redesigned. It's a big project itself. And I think that's an activity that each member state's going to have to do in terms of, well, business case needed, so the cost needed, the time needed, the benefits that they're going to have, and so on and so forth. Where we are helping, and you see some of the countries and some of the cities where we are currently engaged in doing assessments. We've already completed one in Riga. There's one that's ongoing in Tel Aviv, and I'll show you a slide on what we found so far. Estonia is partially complete, and we're now engaged with others. But you can also see that we have many requests from other member states to conduct this airspace assessment. We're also using this mechanism to define a methodology to do the airspace assessment, which is available through the AMC guidance material that was published in the NPA, and it will also be available freely through Eurocontrol website for anyone to make the most of it. It's public knowledge. In addition, a number of other countries have asked us to help them to really kickstart the use-based implementation activity in their countries. I'm personally involved, for example, in Turkey, in Moldova, and Serbia, where we are bringing their people up to speed, but at the same time, what they're finding is, because in this use space and urban air mobility area, we've got conventional aviation and non-conventional aviation actors coming together, like the cities, the local authorities, the planners, the telecom industries, the rail industry, and so on. They have a different way of talking. They have different terminology. They don't talk the same language. And therefore, a lot of these countries are struggling to bring all their stakeholders together, to get them to talk to each other and understand which way they must go forward. And that's an area that we, as neutral people from Eurocontrol, are helping them to bring their stakeholders together and to influence them. So I talked a bit about the Israel thing. In Israel, I would say out of all the countries that we have visited so far, Israel is the most advanced. There's no doubt about it. I think for those of you who were present in Amsterdam Drone Week, we had a whole session for an hour where the Israeli CAA demonstrated what they're doing. Obviously, because of the special needs that they have, let's be honest, because the geographical, geopolitical needs are very different in Israel as compared to other countries. And in there, we have conducted and we've taken their airspace that they wanted to assess, and we have positioned it or categorized it using different categories and color-coded them. I can't give you exact labels of those color codes, but they now know what exists above their airspace, and they're in a position now to identify, perhaps in the green areas, they can run a few operations, but maybe not so in the red areas, and perhaps even the amber areas. In Israel, particularly in Israel, large parts of the airspace are managed by the military for obvious reasons over there, and therefore their challenges are far higher. And we are now going to start conducting a safety assessment, not just using SORA, but also looking at a safety assessment methodology called Medusa that we have at Eurocontrol created, which is to look at the overall airspace design, complete one as such. So just to give you a flavor of where we are helping to implement urban air mobility. Now, the other thing we're also doing is in Bratini, and I was very pleased to hear about the activities happening and also increasing in Galicia, in Spain, where I think there was one of the projects where you highlighted that you're going to develop a simulator, and we are actually in touch, in discussions with the Galician authorities to see if we can see collaboration with them to use the simulator we have in Bretigny, which is today largely more ATM related, but we're trying to make it and extend it to UTM, and in collaboration, of course, also with Airbus, no doubt, to try and create almost like a network of simulators across Europe, where not any one simulation activity will have everything, but together we will have enough so we can support each other, and we can go and use each one of those facilities with an MOU, a collaboration to work together. So that's where we're busy there. Something that's very close to my heart is in 2018, European Commission asked Eurocontrol, EASA, CESAR joint undertaking, and the DG Move to come together to define a network of use space stakeholders, so we can all learn from each other, to share lessons learned. I chair that network myself. We now have around 450 companies from Europe as members, a lot of those from Spain, no doubt, and active members, and thanks to all of them for sharing their lessons with us. Our objective is that not any one community or company or individual can do everything. We have to work together to do it. So we try to bring everything together. The European Commission has empowered us that for challenges that exist to all of you, technological challenges, operational, financial, regulatory, and so on, we have been authorized to take those challenges and be able to go into any government department to seek answers and bring those answers back for you. And we do those via WebExes or through conferences like we did in Amsterdam and so on. And one of the other things that we've done, I'm very proud, and I think you will see that here, is last year we created an inventory of use-based test centers across Europe. When we first started, we thought maybe there are about a dozen of them. We found 50, and I can tell you today there's even more, because I was talking to some of the other colleagues from ITG, and they've supplied the data that still needs to go on it as well. But you can see in Spain already there are a number of them. A lot of those are sitting, you guys are sitting in this room as well. What we're trying to do, and this is where the link comes to the next step in terms of challenge, is this. One of the things that has been mentioned today, and I can inform you certainly from the EU Drone Strategy 2.0 discussions, there's a big drive to create regulatory sandboxes whereas projects like AMU-led, Chorus XUM and others, we can do demonstrations in limited environments for a limited amount of time. But what we can't do and what we need is to be able to do demonstrations that run for a long period of time in different environments, in different weather conditions, looking at reliability, sustainability, predictability, robustness of systems. And I think these sandboxes are needed to be able to provide the infrastructure to run such experiments, as well as at the same time to perhaps even waive some of the regulatory conditions that EASA has, so we can actually do more innovation as such. So that activity is ongoing. Now, I'll pick on some of these challenges. I think some technical challenges have been spoken to about previous speakers. There's no point going in those. But let me pick on a couple of those that haven't been spoken about. The first one I'd like to pick on is financial. Through the network that we run, we know that a lot of SMEs struggle financially, and Martha, you highlighted a few minutes ago as well, and quite rightly so, that technically they're very advanced, and a lot of the innovation takes place in SMEs, in small companies as such, but they need financial help. Now, today, there's good news, and there's more good news in the future. At least today, the European Investment Bank has a pot of money available for SMEs and also large organizations and cities, and you can go and apply for that funding, whether it's a grant for your project planning purposes, or if it's loans on low interest rates that are available. I know that the first speaker talked about similar activity in Spain as well. I think the European Investment Bank is looking at even bigger scale across Europe as such. And the European EU drone strategy that is currently scheduled to be released in October of this year is going to provide a structure for where the future growth is going to be, or where the future emphasis is going to be, such as on regulatory sandboxes creation, also on civil and military coordination. Military has capabilities that the civilian market can benefit from, and vice versa. Bringing in cities and helping local and national regulators to create more competence programs and so on and so forth. So that will go to the European Investment Bank, and they will then create more funding options to feed the European EU strategy as such. So please, if there's one thing I can highlight to the SMEs and organizations sitting in here, look out to the options available from public sources in the European Investment Bank. I'll be more than happy to provide further information should you wish to have more info so you can go down this route. I think the other one that I wanted to highlight, just because it hasn't been covered yet, are things like we also need to create education and competence building training sessions, training companies and training programs across Europe, because as use space and urban air mobility becomes more prevalent, we will need new skills which aren't available today as such, and we will need the skills to be upgraded regularly. So that's also something that from the EU drone strategy that they're thinking about bringing out as such. Societal, someone talked about societal a minute ago. Something else that's going to happen in the future is to create these concept of living labs, they call it, which you could say a regulatory sandbox, but a regulatory sandbox where common citizens should be allowed to come in and witness demonstrations, because what's happening today is every time anyone in our society, just common people, if they think about or they look at the news from drones, is always bad news. You know, counter drones, rogue drones went there, rogue drones did this and all that. So there's a need to change that communication. We need to create better communication mechanisms for people to understand and appreciate, whilst there are risks associated with drones, but look what we've done during the pandemic when a lot of the medical deliveries were conducted and medical equipment was provided to save human lives. And therefore, we want to bring common average people from non-aviation background to come to these living labs and witness themselves on what drones can do. That way we can change their mindsets and we can influence them to support the future as well. I would say also that, needless to say, we need further standards, because today the entry barriers for a lot of the companies are very high. It's because we don't have enough standard scenarios. We don't have standards and performance requirements for a lot of the things. So for large organizations that have big budgets, yes, they can go in there, but for small to medium scale enterprises, the entry barrier is very big. And I think the last slide, and then I think we'll go. EU Drone Strategy 2.0 is being worked at right now. Members of Spain are part of that group. There's a drone leaders group at the level of DGs and CEOs. They're guiding and steering the direction it should go in. It's planned to be adopted by the end of 2022. I think the news for completion will come out the end of October. We've had 3 hearings where I think somewhere close to 20 companies from around Europe have already highlighted what they need to flourish their business in future. So the European Commission is listening to it. Well, I'll leave that picture really for you to look at. It's from a report that European Investment Bank published last year on what the future might look like in terms of what the mobility would look like in future in urban environment. Let's hope it does, but we all have a role to play with it. If you wish to learn more about what we do, please follow us on social media. And we are in the business of supporting European aviation. That's what we do. And integrating drones and AIRBUS in the airspace as an equal airspace user is really close to our heart, to maintain safety of navigation and safety of aviation. That's really where we are. With that, I'd like to thank you for listening to me. And if you have any questions before lunch, which means, please, sir.
First of all, thank you very much for your presentation. It was very professional. It was a good thing to be here and see what you, as a representative of Eurocontrol, is giving to us. So thank you very much. So my question is related to other organizations in the world which are doing same work that Eurocontrol. I mean, thinking in China, thinking in America or Pacific area, or what is the result of this contact I suppose you have with those organizations? Are we learning from them? Are they learning for us? Do you think that the business could have certain influence in the speed of the different organizations like Eurocontrol to implement their own, let's say, US space in their territories? So maybe it could be really a kind of competition in this aspect. So what is your view? Sorry.
Yeah, it's a very, no problem, but it's a loaded question, but the right question. So it's a great question. Thank you for that. First of all, I think there are three parts of the question. What are we doing to work with other organizations in the world? We're doing a lot. First of all, we have regular MOUs or relationship with the FAA and NASA as such, and we have regular dialogues with them almost every 2 months or so. We share each other's best practices. Yeah? We learn from each other. We also run joint seminars between Europe and United States, and they are generally held in Bretigny. Eurocontrol takes it. Likewise, we're closely associated with China, for example. EASA have a chapter which is that they must go across globally to various countries, take delegations from Europe to those countries and bring those delegations here to have interchange. I myself have been part of that on a trip to Shenzhen in China pre-COVID times. So a lot of interaction is being done from that point of view. So certainly, and of course, we are playing a huge role in the ICAO as well at the same time, because on behalf of the member states, European member states, we have people who are based there, who are taking the European way of doing things and promoting them at ICAO level to make sure that they actually get into the, standard practices, future practices, the global management plans, global safety plans, and so on and so forth. And I think the last thing you said was, how else we can do across. So there is a risk, and I will not shy away from that. And I think our Boeing and Airbus colleagues are here. They can also back me up on that. There is a risk that Asia, United States, Europe, South America, Africa, they may come up with different regulations, and different ways of doing things. And that's a risk that I think we must mitigate, because at the end of the day, it's a risk that will be associated with things flying in the air. It will be associated with us. The OEMs will suffer from it, because if they are to produce an aircraft suitable for the African market versus European market versus American market, they will forever be spending time, money, and effort on going through regulations after regulations, because they're all different. So that risk has to be managed. And I'm proud to say at least that in Europe we have recognized, and not just Europe, but also in the United States, we've recognized that. And I think certainly Boeing and Airbus have come together to highlight, this and to harmonize this risk by putting together a task force to try and go across various countries to seek a common, unified, integrated airspace for future. But the risk hasn't gone away yet. We have to manage it. And if we don't manage it, it won't be it won't be advantageous to anyone. Thank you. So, sorry, very long answer.
One last question. Okay, so I think, thank you very much. We can go for lunch. Thank you. Si podemos ir sentando, por favor. Vamos a continuar la jornada. Please, you can sit down. Bueno, vamos a continuar. So we will continue. So after the lunch, after a little bit of the break, okay. So we would like to welcome Carlos Querejeta. He's a senior system engineer at BOEING Research and Technology Europe. He has worked for the past 18 years. During this time, Carlos has led a number of research initiatives in topics like advanced trajectory technologies to support trajectory-based operation paradigm, aircraft performance models, US autonomy solutions, traffic simulation, detect and avoid, and US flight test campaigns. Carlos is now responsible for the simulation activities of the Airspace Operational Efficiency and Autonomy team and the program manager for the US Sky Initiative. So, thank you, Carlos. Welcome.
Okay, thank you, Antidio, for the introduction. I was talking before to Munish during lunch, and I was saying that the real challenge is now. I mean, trying to keep you for having your power nap right after lunch, that's going to be a real challenge. So, at least for the ones brave enough to stay after lunch. So, do we have the presentation here? Okay. So, I will talk during this presentation about how simulation can contribute to the development of advanced air mobility. Topics I will cover, just an introduction, more or less extensive, of advanced air mobility, some motivation and challenges for an advanced air mobility simulation. Then I will go in some detail into the U-Sky initiative, which my colleague Enrique introduced earlier in the morning in the roundtable, just to finalize with some final remarks. So regarding advanced air mobility, we have all seen on TV and on the news these advanced urban air mobility scenarios with hundreds of drones conducting or delivering packages through different points in the city, and maybe some air taxis carrying out passengers from one point of the city to a train station or to an airport. And these scenarios really seem a bit like science fiction, right? But actually, I mean, the ball is already rolling, and most of you here, present here, are working in some way or another towards having these kind of activities become a reality. So the current situation is that the ball is already rolling, and it has been for quite some time. Let's go with advanced air mobility. That's the general term that encompasses just the general concept of the future air mobility. I have to highlight that it not only includes these advanced science fiction scenarios that I was talking before, but also some maybe less known forms of air transportation in the future, like maybe autonomous cargo operations in countryside areas, maybe conducted by conventional takeoff and landing aircraft using some airstrips, right? So it's not only limited to these vertical takeoff and landing drones, but also all kinds of autonomous air vehicles. I will introduce a little bit about urban air mobility. Probably you are all familiar with the term. Obviously, focuses on air transportation on urban areas, but it has some specific environment in which they conduct these operations. So flight times are quite short, maybe in the 20, 30-minute stops, maybe. There's some critical safety implications in these kind of operations, right? I mean, any kind of incident or accident on one of these drones does not only affect eventual people or passengers on board the aircraft, but also people and property on the ground. They have very specific landing spots, like Vertiports. And then there's the acceptability of people. This is an issue regarding noise, privacy, and these kind of things. I mean, there's a lot of effort being put and a lot of investment by the manufacturers in order to develop flight platforms with a reduced noise footprint. And regarding privacy, obviously no one wants a drone with a camera, you know, flying over their backyards. So that's kind of obvious. So all in all, these kind of operations will have their own regulations, and they will have some specific technology solutions. Then these kind of operations are being, you know, pushed strongly both from Europe and the US, as Munish was mentioning before. Although they have their own interests and they have their own technical solutions that, at this point, at least, do not necessarily converge. So in Europe, this is being pushed, this is being promoted by the CESAR joint undertaking, which is funding different EU space initiatives. I mean, most of you are already working in some of these initiatives. And it published the first version of the CONOPS in 2019. And right now they are working in the Chorus XUM, the extension of the CONOPS in order to cover urban air mobility operations. There's also a regulatory package already available, whereas in the United States, this is being promoted by the FAA and NASA under the Next Gen initiative. And that initiative also involves industrial partners. They published, and that is wrong, by the way, in the slide, they published the CONOPS back in 2018 and a second version of it in 2020. So this is just to give a little bit of context. So if we move to the, if we focus on the European approach, which is U-Space, obviously, it will be supported by, it will need a high level of digitalization and automation. And this is going to be provided by a set of services, some procedures that will enable the actual introduction or access to the airspace to different users. And it has to do that for simultaneous operations. And one of the key things here is that these services and these procedures have to ensure the appropriate level of safety and the appropriate level of efficiency. The service are going to be provided by U.S.-based service providers. You already know that. And the users will be bound by contracts to these U.S.-based service providers, just as we are all bound by contracts to the cell phone companies or gas supply companies, right? And there will be an entity that somehow will centralize common critical information. It could be the so-called the Common Information Service Provider that you were talking about this morning in the roundtable. But it could be any other approach. It could be a state entity, or it could be even a decentralized approach, which is the one that is going to be used, or that at least developing in the US. And it's not only, U-Space doesn't only cover these advanced scenarios I was talking before, but also much simpler scenarios that can be conducted, some kind of operations can be conducted right now as we speak. So the U-Space implementation has 4 different phases according to the level of digitalization and automation needed to conduct the operations. So the one with the lesser requirements is going to be U1, which includes only the U-Space Foundation services. I will not go too deep into them, but just think about things like registration, e-identification, which will enable, third parties to access, the identification and the position of the drones conducting operations, and also the awareness. With a higher level of complexity and higher level of digitalization could be U2, which is the U-Space Initial Services. And they're going to include mostly services to support the strategic part of the operation, the autonomy in the strategic part of the operation. And that could be flight plan preparation, flight plan authorization, and strategic deconfliction of the flight plans. But it will also include some additional services more oriented towards the tactical phase of the operation, just for tracking and monitoring purposes. U3 will be even more advanced and more digitalized and automated U-Space services. And that could deal with capacity management, with tactical deconfliction, and, for instance, emergency management. All these kind of services will enable operations in denser traffic areas. And finally, there could be these full autonomy services that would enable these, high science fiction scenario, so to speak. Okay, so let's think just a little bit about how a generic operation of a drone will be conducted in this futuristic scenario. So the first thing that has to be done is to register all the actors that will actually participate in the operation. And that would be the pilot, the UAS pilot himself, the UAS operator, which is the one that will kind of prepare the flight plans and so on, and the air vehicle in particular, right? And then the user, the Airspace operator, will need to define what kind of mission he's going to fly, right? He has to define the flight plan. And to that end, the Airspace service provider will provide some kind of service, web service, for instance, to facilitate the creation of the flight plan. It will probably display a map, and then it will add information from other Airspace services with added value, like, for instance, the weather forecast, or the communications infrastructure coverage, or the navigations infrastructure coverage, or maybe some digital terrain elevation models, everything that is needed in order to model the trajectory of the flight plan that you want to fly. So let's say that you have already defined what you want to fly, but then you have to get the authorization to fly it. And to that end, there will be yet another USSP, Airspace Service Provider service, in charge of authorizing this flight plan. And it will have to check that this flight plan has been defined according to current rules. It will have to double check that the pilot and the air vehicle are certified to conduct that kind of operation. And then it will have to double check for conflicts with previously approved flight plans. And if you think about this, we are thinking of an environment with several USSPs, and then one USSP in particular will need to access previously authorized flight plans from other USSPs. And to that end, we'll need to somehow communicate with this centralized entity, which is the Common Information Service Provider, through another Airspace service. So just think about how many services are going to be needed in order to conduct this operation. And we're just in the strategic phase. So if we move to the tactical phase, which, I mean, comes the day where you want to execute your mission, first thing you have to do is to activate your flight plan. It has already been approved, and you are almost ready to take off, and you want to have the clearance to actually start your mission. So again, you will need another Airspace service to obtain that clearance. After that, you're cleared for takeoff. You take off, you conduct your mission, and throughout your mission, your air vehicle will have to somehow publish its information, make it available to the Airspace domain. That could be in a number of ways. It could have an ADS-B transponder, it could have a UTM transponder, it could be the telemetry going to the ground control station, and the ground control station sending this information to the Airspace domain. But again, this information will be kind of gathered by a centralized Airspace service, the tracker, and will gather information from all the traffic operating in the same area and generate the traffic tracks. And then one other thing that has to be done during the operation for the Airspace domain, for the services in the Airspace domain, is to monitor the flight. I mean, there have to be services that double check that the aircraft is flying the actual flight plan that was authorized, that you don't deviate from that. Otherwise, it could raise an alert. In more advanced scenarios, there could be some tactical conflict detection and tactical conflict resolution services that will check that you are maintaining separation with respect of the remaining traffic. And otherwise, it will take action and command some kind of flight maneuvers in order to ensure that separation is maintained. So just think, there's emergency management there. I mean, I'm just talking about the nominal operation. Just think about things are not always going to go nominal. There can be some kind of issue in the air vehicle. You can lose your link communications with the ground control station. You can lose one of the engines. Things can happen, right? And you have to, there has to be something that kind of manages these critical situations. Okay, so this is, at a very high level, the different steps that have been conducted in order to do a drone operation in the future. And just think about having hundreds of these operations simultaneously. And that's really a clear use case where simulation can help. And it can help first in identifying weak links in the Airspace solution. I'm talking about a proposal of solution, not about a final solution covering all the regulations. And maybe evaluate the performance of some of the advanced services or some of the onboard systems. Okay, let's see now some motivation and challenges of the of an advanced air mobility simulation. First, CONOPS regulations and all the related technologies to use space have to be validated up front. They have to be checked and validated before they are put into service. Then, now it's very common the use of live demonstrators to showcase and evaluate use space technologies and services. And this approach can be complemented with simulation as first, it is very expensive. I mean, those of you that have experience in conducting flight tests know that that's really expensive to do. And also it's really time consuming and the progress is really slow as compared to just doing simulations. And second, this kind of, let's say, live demonstration don't exercise the system in a wide range of possible advanced air mobility scenarios that could be eventually needed to validate the systems that are being tested. So in this context, the advanced air mobility simulations will become fundamental to first help facilitate the standardization of verification and validation processes, and second, to evaluate, as I mentioned, the performance of different systems, services, and technical solutions, and do this in a wide of let's say, in a very wide of different scenarios with different maybe traffic densities and so on. But the simulation is not the solution to everything. I mean, it's not the silver bullet, and there are several challenges that prevent simulation from being the perfect tool that I'm, kind of saying right now. The first one is the incomplete definition of advanced air mobility or use space of this environment. I mean, it was already brought up this morning in the roundtable. I mean, regulations are not complete yet, and we cannot wait for regulations to be complete. We have to provide tools that help regulators actually regulate. Then there's a lack of standards for data information exchange. So some of the regulations right now talk about what information is needed and explain in some detail. For instance, the flight plan I was mentioning before explained there has to be a 4D trajectory and some other information that has to be included as part of the flight plan, but we don't have the actual format, the actual communication protocols that have to be used. So you just have to figure it out and do a proposal and maybe change that in the future because there's no standard right now. Eventually, these kind of simulations can help into defining the standard. Integration with air traffic management, that's really a key issue, a key challenge. I mean, if you're talking about simulation, there are several air traffic management simulations. There are no, let's say, wide use space simulations, and you have to put both of them together and be able to test all the coordination with air traffic management. And that's not an easy task. It's really challenging. Another thing that is a challenge is the simulation of advanced air mobility air vehicles and ground infrastructures. I mean, if you think about these vehicles in the future, for instance, air taxis, you don't have publicly information available on the performance of these vehicles. Maybe some rough data that is not enough to create a simulation model that is of sufficient, fidelity. And we cannot even think about what will the actual vehicles be in 5 to 10 years from now. So it's really challenging to model or define simulation models for something that actually doesn't exist yet. And sometimes the configurations of these vehicles is pretty different from the ones from the manned aviation that we know of, right? You can think of summer taxis that will take off vertically, but then will fly as a fixed wing because it's more efficient. But there are just a handful of such vehicles in manned aviation, and there's not enough performance information to derive a simulation model. And another thing is the very difficult weather prediction in low altitudes. If I was asked to provide or to say what is the biggest source of uncertainty regarding the trajectory prediction of a drone, for a drone mission, for instance, I could say hands down is going to be the wind prediction. It's not going to be, I think, how good your model is, your aircraft model is. It's not going to be how accurate you integrate the equations of motion. Is going to be your wind prediction, because especially in low altitudes where these kind of missions are going to take place, it's very difficult to provide a prediction for the wind. You have a very complex viscosity effects in the wind near the Earth's surface, and you also have the turbulence created by different buildings and constructions. So it's really a challenge to have an accurate wind prediction. An additional challenge is the lack of real data to contrast the performance of your simulation. I mean, if you think about air traffic management, it's really easy to have a reference to be able to assess whether your simulation is good or is completely useless, right? And you just grab an ADS-B receiver and you instantly have tons of aircraft tracks, right? Of real man aircraft tracks, and then you can, use this data to contrast with your simulation. There's no such thing in the US space environment, right? We don't have any real data, any actual real data to contrast the simulation. Maybe for simple scenarios in a very controlled environment, but not for these futuristic scenarios I was talking before, not for these urban air mobility scenarios. And then another of the challenges is the support to hybrid simulations. That is simulations in which real aircraft are flying together with virtual traffic that is generated by simulation. So that's also a challenge, but the outcome from that can be really, really useful in order to advance into advanced air mobility. So let's talk now about the Galician USky initiative. This was briefly introduced by my colleague Enrique in this morning session. The motivation, I think I already talked about what would be the motivation, right? Is going to be to complement the different U-Space initiatives that are more focused on live demonstrators than on simulating a complex or a wide U-Space environment. Also, to anticipate the future needs of U-Space stakeholders on training, test, and evaluation of U-Space technologies and solutions. And this is in line with what I said before, to provide tools or to provide help to the regulators to help them regulate, right? And also is to boost innovation in the aerospace domain in the Galicia region, in the Galicia area. The context means that there are several solutions that have been developed during this civil UAS initiative in the pole of Galicia that want to be leveraged together with a simulation in U-Space. And CDTI, which is funding this initiative, and GAIN, published a request for proposals in the third quarter of 2021, and two solutions were awarded. One is USky. And well, let's talk a bit about the purpose of this simulation, what we are trying to attain in this simulation. First, we want to be able to do representative simulations of U3, U1, which is not really a big deal, to U3 scenarios. U2 would be something like in between. You would have interoperable U-Space services. So the thing is that we don't have a set of services that are fixed, but you can, plug some additional service in or replace some of them with alternative implementations. That is going to be really useful as, regulations are published. It has to provide human-in-the-loop and batch simulations. For human-in-the-loop, you can, do some kind of training for operators or training for pilots, something like that, or see how the overall U-Space domain, works together. But with batch simulations, you can derive meaningful metrics, minimum key performance indicators that can eventually assess whatever you're trying to assess in your simulation exercises. Be it the performance of services, be it the impacts in safety in a change in the CONOPS or whatever. The simulation will have a special focus on the coordination with air traffic management and also the contingency management. As I mentioned before, in the future, operations are not going to be always nominal. The world is not perfect. Your predictions are not going to be perfect. So in the end, there will be issues. There will be problems with the air vehicles. There will be losses of separation with respect of other traffic. And all these, we have in mind to try to cover in this simulation infrastructure. Open interface to facilitate the integration of third-party simulations and solutions. We don't want this to be a closed simulation. We want to have an open interface, call it a self-development kit if you want, that provides a wide set of interfaces to access key functionality within the simulator, so that eventually you can integrate your own third-party solutions, even whole simulators, into this USky simulator. Strong and flexible data analysis capabilities to evaluate relevant key performance indicators. I've already mentioned that. If you want a simulation, if you have a simulation, it has to cover some purpose, right? And this purpose, in the end, you will need some kind of tangible numbers that, you can use to analyze what you wanted, what you intended when putting in place your simulation scenarios. And also complying with current use-based regulations and scalable to support future regulations. This is really a challenge as well. I mean, we know what the current regulation is, but we don't know what the regulations in 5 years from now is going to be. So we are trying to do this as flexible and as modular as we can in order to provide some kind of support to future regulations. So this is kind of the program overview. So the customer is, CDTI is funding this initiative, and the customer is the Galician Institute of, Galician Innovation Agency. And the funding is going to be 5.3 million euros, and the project time frame is 15 months. And 15 months to develop a simulation like the one I just presented, that's really a tight time frame. I mean, you cannot start from scratch. And this program is being led by us, by BOEING, but we have 8 other partners that you can read here. I mean, Entity Data, CESGA, ENAIRE, ITG, Centum, Grida, Gradient, Aslogic. I mean, the names speak for themselves. I mean, these are really well-known companies in the fields of autonomy, use-based, air traffic management, IT. So, and we couldn't expect, better partners to accomplish this. To work in the simulator and to accomplish the objectives that we have set. I will talk here a little bit about the scope of the simulation. I mean, we have all seen that use-based is, it's kind of a monstrous activity. It covers a very, very wide range of different missions, of different purposes, of different activities. And the one thing that we have to do first, especially when we talk about a 15-month time frame, is to clearly define what the scope of the simulation is. And we have done that by identifying business cases. So in the end, the simulator is going to be a product for our client, right? And he will expect to exploit that. And we have to identify some business cases which could eventually provide some profit to the client, right? Out of these business cases, we have identified some use cases that support them. And out of these use cases, we will eventually identify the different design artifacts. I mean, the different actors, the different components of the simulation, the interfaces among them, the interactions, the requirements, and so on. And I will only stay here in the business cases. I will not go down through the use cases. I could stay here all day, but I will just enumerate these business cases. Think that these are the business cases we're trying to provide support with the simulation. So the first one is evaluation of CONOPS and proposed regulation. So let's say that someone is working towards developing some particular aspect of a regulation and wants to provide an assessment of what are the impacts in terms of safety and in terms of efficiency of some particular detail of that regulation. So the idea is that the simulation with modeling several complex scenarios can be run in order to obtain this kind of metrics that will help the client, to identify whether their proposals are good or are not so good. Evaluation and support to certification of use-based services and USSPs. Just bear in mind that I want to highlight that I say support to certification and not certification. I mean, this simulation is not meant to be used in a certification entity, right? It's just to be used as a previous step for some clients to have the guarantees that they can face a probably more expensive certification process, and they can use their system within a simulation in order to get some aspects of it, some metrics from it, that guarantee that they are going to pass the certification process. USSP and CA and Common Information Service Provider operator training. They won't be matched that the operators of the USSP and the Common Information Service Provider will be doing. And thinking now, one of the things that maybe can be trained at is that in the current regulations are talking about the dynamic reassignment of the reconfiguration of the airspace, right? So that is something that can be done through the Common Information Service Provider, or maybe can be done through ATC. And that is something that maybe the operators in the future will need training in order to see what the effects are, how to do that, and that is something that we want to cover in the simulation. UAS pilots and operator training, that's another thing. So As of now, if you want to have your drone operator license, you have to do an exam, and then you have to do some practices with some really simple, flight patterns. But in the future, in this environment full of use-based services, you will have to know how to operate within this ecosystem of services. And some kind of complex simulation that gets the user in this environment and gets him used to actually operate in it is going to be needed. So that's one of the other things that we are aiming at. Then the evaluation of coordination protocols between U-Space and air traffic management. Evaluation of contingency protocols in U-Space. These contingency protocols have to do with a previous project that... Sorry? No. Ah, yeah. Thank you. Is that from now or from a minute before? Okay, yeah, I think in 10 minutes I'll be done. So I was talking about evaluation of contingency protocols in U-Space. One of the projects we did in Galicia is the Skyway project. Some of you were involved in the project, and it had to do with managing contingency situations and coordinating that with ATC in current environment with no U-Space. Right now, what we want to do is to leverage that and to propagate this kind of contingency management to the U-Space domain. Evaluation of onboard autonomy solutions. Again, say that a client has developed a very nice detect and avoid solution that wants to be tested in a U-Space environment. That's one of the other things that we want to be able to tackle. And then support to fleet management and optimization. So all in all, just as a wrap up of this slide, these will all require an advanced data analytics capability in order to evaluate the safety and efficiency of the operations by means of relevant key performance indicators. Well, I will go really quick in this one. We use this diagram in order to explain the different domains of the solution, which is really straightforward to understand. We can think of 3 domains being playing in this field, right? On the right side in red is the UTM domain. You can think of it as U-Space. It could be made up by the different U-Space service provider, the common information service provider, and we think of it as an invariant domain in the sense that the particular services and the interfaces with the services and the functions of the services are going to be the same regardless their client being actual aircraft or simulated aircraft. So that's one thing to take into account. Then there's the air traffic management domain. I will not really stop very much on it. And there's another domain, which is the simulation domain, which is in the center, and it overlaps slightly the air traffic management domain and the UTM domain. And that's what this U-Sky simulation domain is going to be, right? It will contain all the components that will make the simulation of real aspects of flight, like the traffic engine, some events engine, some onboard autonomy. It will have also an interface, as I mentioned, to third-party components. And, well, I don't have much time, so I will skip that. This should be kind of the deployment we are thinking. We are thinking about full cloud deployment of the whole solution, both on one side, the U-Space domain, and also the simulation domain. And this is going to be done in CESGA, in the Galician Center of Supercomputation, in a way that we will have some web clients in order to manage and configure the simulations and obtain also the analysis and the metrics that we want to have. And there will be kind of a lab in this year. And let's go to the next one. Okay, so the starting point, as I mentioned, 15 months is not enough to conduct this research, to conduct this project from scratch. And we have 2 solid pieces of technology that we are starting off from. First is the air suit that our colleague Pablo has been presenting this morning during the roundtable. It's a complete suite of U-Space services with their web interfaces to enable UAS operators to do all kinds of all the stages of operation in U-Space, right? The flight planning, the execution, and so on. And it's fully aligned with the recent European regulation. And as he mentioned, I mean, as of January, they are already accommodating the AMCs. So And the other big piece, piece of technology we are being supported on in this project is the Skyway Simulator, which I already mentioned, which has to do with managing of contingency situations. I will not go through all of these bullets. So just some final remarks until Antidio says that I'm done. So technology demonstrators are not sufficient to assess the safety and security of advanced air mobility systems. So in this sense, advanced air mobility simulations place themselves as a key asset for the development and evolution of advanced air mobility concepts. Advanced air mobility covers a very wide range of applications, and the simulations have to clearly define what the scope of the simulation is. Advanced simulation data analytics capabilities are fundamental to add value. As I mentioned, this computation or evaluation of key performance indicators. There are numerous challenges involved in the development of advanced air mobility simulation infrastructures. And the USky program was conceived for the development of this comprehensive use-based simulation that aims to cover a representative set of business cases. It leverages past US-based and simulation capabilities, initiatives like Skyway and AIRBUS, in order to create this comprehensive use-based simulation. And last, the USky simulation will integrate different assets that are present right now in the CR in order to open the door for more representative hybrid simulations. I think that's all. I was a bit in a rush in the last slides, but still.
Thank you.
Thank you.
A little bit of time for one question or two fast questions. So anyone in the audience who would like to?
I have one. No, go ahead.
I'm sorry, there's just time for easy questions. So.
No, it's an easy one. Are you planning to feed the authorities with the data gathered during the project or after the project?
Can you say again, please?
Are you planning to feed the authorities with the data that you gather during the project? At the end, I think you will...
Well, not yet. Not yet. I mean, we're planning to put the foundations of this simulation and to be able to model different complexity traffic scenarios and to be available to gather data from that, but we are not going to share that with the authorities yet. I mean, unless there's a clear interest from probably the authorities.
Thank you.
The question was related to the urban air mobility simulation of the aerodynamic effects that you mentioned. That is complex, I agree, but you can mention something more, what you did and how are you...
Well, I was just mentioning one of the challenges of such a simulation, not that we did. I think we did some of that during the Skyway project. I don't know if Enrique has more information on that, this micro-weather...
Yeah, well, we have run a number of projects dealing with micro-weather computations, and we have developed a kind of a tool that is able to transform mesoscale forecasts to micro-scale weather prediction, including not only wind, but turbulences, pressure, temperature, but it's not that easy, and we are trying to test and validate some of the developments taking advantage of this simulation infrastructure. We are in the process of having a micro-weather service, but not really there yet.
Do you plan to validate this, or how to validate?
Yeah. Being honest, we are thinking of how to validate this. At the end of the day, we need to take data from a real urban air mobility environment, maybe put in some sensors in the city. I don't know, but first of all, we're going to have a kind of robust process to forecast micro-weather data.
Good, thank you.
Okay, so thank you very much. I think we conclude. Thank you. So now we continue with a second roundtable on UAM infrastructures. So please, everybody that is going to participate, come to here.
Well, good afternoon. We have been asked to switch from English to Spanish for this roundtable. So, buenas tardes, mi nombre es Iván Maza, soy profesor de la Universidad de Sevilla, miembro del grupo de investigación AIRBUS Robotics Lab, dirigido por el catedrático Aníbal Ollero, que nos va a acompañar en la siguiente mesa redonda. Y también soy un investigador de los que está involucrado en la iniciativa IMOV 3D que se ha comentado a lo largo de la jornada. En esta mesa redonda vamos a abordar las infraestructuras habilitadoras para la movilidad aérea avanzada. Y bueno, para mí es un honor moderar esta mesa redonda que cuenta con profesionales del más alto nivel dentro de esta área. Vamos a estructurar la mesa en 4 ejes fundamentales. Por un lado tenemos los vertipuertos y aquí nos acompañan pues Alberto Barreiro de Ferrovial Vertiports, también Carlos Berenguer de AERTEC. Otro pilar importante es la infraestructura de comunicaciones. Bueno, para eso tenemos aquí a Ángel Alves de Telefónica. Otro punto interesante y fundamental es la infraestructura de ayuda a la navegación y para eso bueno, tenemos a Carlos Hernández de Telespacio y por último toda esta infraestructura al fin y al cabo es una ayuda para la realización de operaciones aéreas y bueno, para hablarnos de ese tema pues tenemos aquí a Santiago Soleil de PILDO Labs. Muchas gracias a todos por participar en esta mesa redonda. Voy a hacer una breve presentación de cada uno de vosotros y lanzaros unas primeras preguntas y luego iremos pues cambiando de un participante a otro y luego a ver si tenemos margen para hacer algunas preguntas por parte del público. Voy a comenzar por el área de vertipuertos con Alberto Barreiro, que es responsable de red y plan de negocio en Ferrovial Vertipuertos. Es ingeniero aeronáutico con 14 años de experiencia en aviación. Su experiencia profesional se enfoca en la planificación aeroportuaria y plan de negocio. A lo largo de su carrera ha participado en la elaboración de planes maestros de aeropuertos internacionales, desde las previsiones de demanda hasta el dimensionamiento y planificación de la infraestructura. También ha participado como miembro del equipo de plan de negocio en procesos de concesiones y transacciones aeroportuarias en España, Francia, Brasil o Turquía, desarrollando proyecciones de ingresos y costes operativos, así como dimensionando el CAPEX necesario para la ampliación de la infraestructura aeroportuaria. Tras unirse a Ferrovial en 2019, comenzó a analizar el ecosistema de la AAM desde el punto de vista del operador de la infraestructura y es el responsable de desarrollar una herramienta de análisis de mercado AAM y su modelo de demanda. Recientemente ha participado en el grupo de trabajo de EASA para el desarrollo de las Prototype Technical Specifications para el diseño de vertipuertos. Alberto, como desarrollador de infraestructuras, ¿cuáles son los principales desafíos a nivel global a los que se deben enfrentar los vertipuertos para ser operativos?
Bueno, primero, muchas gracias, Iván, por la presentación y bueno, a los organizadores por traerme hoy aquí. Los principales, me sale en inglés, disculpad, challenges que enfrentamos a la hora de poner en marcha los vertipuertos, yo los clasificaría en 4 grupos, básicamente. El primero de ellos se ha hablado ya bastante hoy aquí, es la regulación. No me voy a extender mucho sobre ello, pero sí mencionar que no solamente estamos hablando de la regulación a nivel de espacio aéreo, que probablemente sea la que más complejidades entraña, como hemos estado viendo hoy, sino también la regulación a la hora de tener una normativa clara para el diseño de vertipuertos, porque a día de hoy básicamente lo que estamos haciendo es acogernos a la normativa que rige el diseño de helipuertos y de aeropuertos, porque es un pequeño mix entre ambos el que estamos utilizando, dadas las características de performance de estas aeronaves. Pero hay una tercera parte bastante importante, un poco olvidada normalmente cuando se habla de esto, que es normativa de usos del suelo. Al final, estos vertipuertos tienen que estar ubicados en algún lugar y ese lugar, por muchos condicionantes, pero fundamentalmente porque este modelo de negocio está predicado en el tiempo, en la reducción de tiempo. Esa reducción de tiempo obliga a tener unos tiempos de acceso cortos, o sea, tienes que estar cerca de tu demanda y tu demanda está en las ciudades. Con lo cual, tus vertipuertos tienen que estar en las ciudades. Y en las ciudades hay poco espacio disponible. No hay mucha disponibilidad de superficie para desarrollar estas infraestructuras y la que hay a veces no tiene los usos necesarios para desarrollar la actividad que queremos desarrollar. Y es algo que también hay que tener en cuenta a la hora de pensar dónde colocar tus vertipuertos, porque muchas veces se da una imagen en la prensa, no desde los profesionales, por supuesto, pero de que un vertipuerto se puede colocar prácticamente en cualquier sitio, en la azotea de un rascacielos, encima de un edificio de aparcamientos, y esto no siempre es posible. De hecho, la mayor parte de las veces no es posible, por múltiples razones, con lo cual es un problema que hay que afrontar también. Luego el tema de la aceptación social. La aceptación social es muy importante porque al final son tus futuros usuarios, son tanto nuestros como operador aeroportuario como de los operadores de los vehículos. Hay que empezar, yo creo, y se está empezando a hacer en algunas partes, a educar a la comunidad en realmente los beneficios que tiene este nuevo modo de transporte y los pequeños impactos que los tiene negativos, pero darles un marco más real. Hacerles entender que esto no es, como muchas veces se habla, un coche volador ni un taxi volador. Tú no vas a pedir el servicio y va a venir a buscarte a donde tú estás. Tú no vas a coger este vehículo y lo vas a conducir por tu propia cuenta. Esto va a estar igual de regulado que la aviación comercial tradicional, es seguro y está controlado. Esto es algo importante que la gente tiene que entender para empezar a generar confianza en este nuevo modo de transporte. Y aquí, pues, la industria tenemos un papel importante en cuanto a comunicar esto y hacer entender también a la prensa convencional que hay que empezar a cambiar este tipo de términos para que la gente no se piense que es que en 5 años va a tener a cualquier, entre comillas, indocumentado volando por encima de su cabeza. No, este no va a ser el caso y es algo importante a la hora de conseguir la aceptación social. Esos son para mí los dos principales. Luego también hay otros dos challenges, si sale la palabra en español, disculpad, importantes, que son más técnicos quizá. Uno es el suministro de energía. Estos vehículos son muy demandantes de suministro de energía y aunque un vertipuerto no va a tener mayores necesidades de consumo eléctrico que, por ejemplo, un centro comercial, sí es verdad que queremos colocarlos en zonas estratégicas y tenemos que asegurarnos de que vamos a tener ese suministro de energía. Y luego la última y la más importante de todas es la voluntad política. Sin voluntad política, todo lo que hagamos al respecto no va a valer para nada. Y este está bastante vinculado también con el tema de la aceptación social. Al final, si tus votantes quieren algo, es más fácil que los políticos empujen a favor. Y el tema de los usos del suelo. O sea, que es un poco, está todo comunicado.
Muchas gracias. En este ámbito, pues una curiosidad que me surge siempre es cuáles son los criterios de diseño específicos que tienen los vertipuertos que no coinciden con los de helipuertos o aeropuertos convencionales.
Pues al final todo depende de dos factores fundamentales. Uno es la performance de las propias aeronaves y otro, como hemos comentado, el modelo de negocio. Empezando por el último, como he comentado anteriormente, este es un modelo de negocio que se basa en el tiempo, fundamentalmente, mucho más que la aviación tradicional. Al final no estás compitiendo con los helicópteros ni con los aviones, estás compitiendo con los coches, con el AVE, con los trenes, con lo cual tienes que ser capaz de proveer un servicio en mucho menos tiempo que esos modos de transporte, porque vas a ser, no ostensiblemente, pero vas a ser más caro que ellos. Hay dos modelos de negocio dentro de este mundo, por así decir, el puramente UAM, o sea, servicios intracity, y luego la conexión regional, como por ejemplo el que presentaba LILIUM, de conectar pares de ciudades. El servicio intracity es todavía más susceptible a este factor tiempo, porque al final tus tiempos de trayecto son muy cortos, con lo cual tu tiempo de acceso al vertipuerto tiene que ser muy, muy rápido. Y esto te condiciona la ubicación y la ubicación te condiciona el diseño, fundamentalmente. Al final hay que tratar de colocar una infraestructura que tiene ciertas características similares a un aeropuerto, en cuanto que tendrá una pequeña terminal para procesar pasajeros, tendrá varios puestos de estacionamiento dependiendo del volumen de demanda, pero que básicamente es una FATO, una zona de aterrizaje para helicópteros, o dos, las que hagan falta, con lo cual es un mix de diseño entre ambos, entre aeropuertos y helipuertos, y constreñido dentro de un entorno urbano. Eso es, así a grandes rasgos, yo creo, las principales necesidades en cuanto a diseño, características especiales de los vertipuertos.
Muchas gracias. Has comentado lo de los modelos de negocio. ¿Identificáis algunos riesgos específicos dentro de cara a lanzar la inversión, de montar el
principal riesgo es que esto a día de hoy es un acto de fe, sobre todo en los primeros años. O sea, nosotros creemos que esto va a funcionar. Lo que no sabemos es cómo de rápido va a funcionar, como nosotros queremos que funcione. Esos primeros años van a ser críticos, probablemente. Entonces hay formas de minimizar ese riesgo. Es el clásico start small y empezaremos pequeños y veremos cómo funciona, ir creciendo a medida que vayamos validando la demanda y viendo cómo puede evolucionar en función de lo que teníamos en nuestras previsiones.
Muchas gracias. Dentro del área de Vertipuertos tenemos también con nosotros a Carlos Berenguer, que es el director general de aeropuertos de AERTEC Solutions. Es PMP, MBA, ingeniero aeronáutico por la Universidad Politécnica de Madrid y complementó sus estudios en la Universidad de Cranfield, en Reino Unido. Aunque inició su vida profesional en planificación estratégica con AENA, pronto se desplazó al sector privado. En AERTEC ha liderado decenas de proyectos en los últimos 18 años, principalmente a nivel internacional en Irlanda, Oriente Medio y Latinoamérica. Además, gestiona la división de aeropuertos en AERTEC con un equipo humano de más de 130 personas a su cargo que desarrollan proyectos de consultoría e ingeniería. Lidera personalmente el Comité de Urban Air Mobility y Sostenibilidad en la división de aeropuertos, lo cual es un ejemplo de la importancia que tienen estas disciplinas en el presente y futuro de AERTEC. Carlos, AERTEC es una compañía fundamentalmente aeronáutica, tenéis drones de ala fija como el Tarsis, y sin embargo, estuve consultando vuestra página web y estáis desarrollando proyectos dentro del ámbito de Vertipuertos. ¿Puedes comentarnos brevemente alguno de esas iniciativas?
Sí, claro, por supuesto. Bueno, en primer lugar, para mí es un placer estar hoy aquí con vosotros y pasar una jornada completa hablando de Advanced Air Mobility. Nosotros ya en el pasado desarrollamos el diseño del Centro Experimental Atlas, donde LILIUM, por ejemplo, está probando hoy sus modelos, y también diseñamos el proyecto de Zeus, ¿no?, que está en construcción hoy en día. Pero creo que es importante dejar claro que el desarrollo y el diseño de este tipo de infraestructura es una realidad hoy. Y voy a dar 3 ejemplos muy breves en los que estamos trabajando. Hoy en día estamos colaborando con OpenVia Air en el desarrollo de un white paper de diseño de vertipuertos, donde prima claramente la experiencia del pasajero, la sostenibilidad de la propia infraestructura, la recarga sostenible en la medida de lo posible de esos vehículos y la flexibilidad. Hablamos de buscar soluciones no solamente para el terreno, sino también sobre edificación y en plataforma marina. Otro ejemplo es que estamos trabajando en un I+D en Alemania para el desarrollo de una red de vertipuertos en Hamburgo, y básicamente la sostenibilidad y la flexibilidad de los mismos vertipuertos es clave. Un tercer ejemplo es el proyecto Aureo Air Mobility City, que es básicamente la transformación de un pequeño aeródromo en la región central de España para convertirlo en un vertipuerto con un número muy relevante de posiciones para eVTOL. Y nuevamente la experiencia del pasajero, la sostenibilidad y el diseño va a estar muy orientado a la propia evolución que la electrificación va a tener en los próximos 10 o 15 años. Son solo 3 ejemplos reales de lo que está pasando hoy en día, de lo que nosotros estamos gestionando hoy en día, aparte de una serie de oportunidades que estamos también visualizando en Medio Oriente, en Omán, en Arabia Saudí y en Emiratos.
Muchas gracias. Habéis hablado los dos de sostenibilidad a lo largo de la mañana. Se ha insistido en la importancia o que alguno de los puntos fuertes de los eVTOL es la sostenibilidad. Entonces, quería preguntaros a los dos acerca de eso, precisamente, acerca de cómo conseguir que el vertipuerto esté a la altura de los eVTOL en términos de sostenibilidad.
Sí. Bueno, si te parece, empiezo yo. A ver, al final el eVTOL es un vehículo eléctrico que no utiliza combustible fósil, con lo cual la emisión de CO2 y otros contaminantes no existe. Además, desde un punto de vista de ruido, los fabricantes están haciendo un gran esfuerzo por que las emisiones de ruido sean pues muy inferiores a los equivalentes, ¿no?, los helicópteros. Eso es absolutamente clave, ¿no?, y es claro. Sin embargo, cuando hablamos de sostenibilidad dentro del Advanced Air Mobility, es importante analizar no solamente el propio vehículo y ese movimiento, sino qué estamos provocando, ¿no?, como en las dinámicas de movilidad urbana. Y es que al final, cuando se generalice el uso de estos vehículos, vamos a conseguir que se reduzca el tráfico rodado y esas emisiones que proceden de allí pues, se van a minimizar, ¿no? Y ese es el gran efecto. Además, se lo dice la Unión Europea y a través de sus motores de desarrollo de I+D como SESAR lo ponen de manifiesto y buscamos, obviamente, que el sector aeronáutico se desarrolle con cero emisiones, ¿no? Es la clave. Al final, estos vehículos van a tener que ser alimentados con electricidad y es clave que la producción de esa electricidad sea, obviamente, limpia, ¿no? O sea, ese es un reto muy importante al que nos enfrentamos. Algunos de los fabricantes hablan de desarrollar vehículos alimentados por hidrógeno. Es una tecnología que no está madura, aunque hace ya algunos años nosotros, por ejemplo, participamos en un I+D para alimentar un dron, una aeronave no tripulada con hidrógeno, pero esa tecnología todavía no está madura. Con lo cual, son soluciones necesarias, pero hay que fijarse en la fuente de la producción de esa energía, ¿no? Para asegurarnos de que estamos hablando de un entorno realmente limpio, ¿no? Al final, el ciclo de vida de un proyecto hay que mirarlo desde la perspectiva, desde la planificación hasta la propia construcción donde se emite CO2, hasta la operación, ¿no? Que es el periodo más largo del proyecto. Y ese análisis hay que hacerlo desde un punto de vista inicial y de diseño, no solamente pensando en la eficiencia energética de la propia infraestructura, sino en soluciones que a veces son más simples, ¿no? Simples desde un punto de vista de soluciones pasivas, que los diseñadores somos conscientes que se pueden tomar determinadas decisiones que reducen muchísimo el consumo energético de nuestras infraestructuras.
Muchas gracias. Quería también saber la opinión de Alberto en relación a la sostenibilidad y también en relación a el impacto de los vertipuertos en las comunidades cercanas y demás.
Sí, no, bueno, lo primero suscribo todos y cada uno de los puntos que acabas de mencionar. Por dar algún ejemplo del caso práctico, bueno, para el diseño que estamos haciendo ya del primer vertipuerto que vamos a construir en Florida, en el aeropuerto dentro del aeropuerto de Palm Beach, estamos incorporando ya medidas específicas dentro del diseño del vertipuerto para que este sea la primera, o creemos que sea una de las primeras infraestructuras de transporte aéreo con cero emisiones de carbono. Estas medidas incluyen algunas muy comunes y conocidas como generación on-site, con paneles solares, pavimentos solares, etcétera, que abastezcan el consumo del edificio, porque sabemos que no podemos aspirar a dar toda la energía que requieren las aeronaves para recargar, y para esto lo que estamos haciendo es, en conversaciones con los proveedores de electricidad locales, asegurarnos una fuente de energía certificada como verde o de procedencia renovable. También estamos incluyendo que todos los procesos que tengan dentro del vertipuerto y que requieran energía sean energía eléctrica, como los vehículos de remolque de las aeronaves, por ejemplo. Obviamente, la infraestructura va a estar certificada bajo los estándares habituales, no solamente para edificaciones, como el LEED, por ejemplo, al que estamos acostumbrados, sino para toda la infraestructura, desde la etapa de concepción, diseño y operación, como es la certificación Envision, por ejemplo, que es de mayor uso allí en Estados Unidos. Y luego, al respecto de tu segunda pregunta en cuanto al impacto de los vertipuertos en la comunidad, no vamos a mentir, obviamente hay impactos negativos, pero creemos que son de menor importancia y muchos menos que los impactos positivos. Sabemos que estos vehículos tienen una emisión de ruido muy inferior al de cualquier otra aeronave comercial actual, pero no nos podemos comparar con ellos, porque no vamos a estar en el mismo entorno. Vamos a estar en un entorno urbano, con lo cual nos tenemos que comparar con el tráfico rodado, con el ruido ambiental de la ciudad. Y a este respecto estamos trabajando con algunos de nuestros socios y algunos de los fabricantes de aeronaves para crear simulaciones basadas en grabaciones reales de los vehículos, para empezar a compartir con la comunidad, que vean que realmente el impacto acústico no es significativo y sobre todo teniendo en cuenta que no vamos a tener vertipuertos al lado de zonas residenciales. No es necesario. Con lo cual el impacto sobre las casas de las personas es bajo. Y el resto de impactos creemos que son positivos. O sea, al final hay un impacto económico positivo. O sea, al final, como cualquier nueva actividad, genera valor, crea puestos de trabajo, genera actividad económica en la región en donde se implanta. Vamos a mejorar todo el ecosistema, va a mejorar la conectividad de las comunidades a las que va a servir. lo que ha mencionado mi compañero de la reducción de la congestión en las carreteras, al final competimos básicamente contra el vehículo privado, vamos a quitar coches de las carreteras, vamos a reducir la congestión, vamos a reducir las emisiones, vamos a mejorar la calidad del aire de las comunidades que viven en las zonas donde demos este servicio. En definitiva, creemos que vamos a mejorar, bueno, estamos convencidos de que vamos a mejorar la calidad de vida de las personas que vivan en el entorno, ya no inmediato, sino de las regiones servidas por los vertipuertos.
Muchas gracias a los dos por vuestra visión acerca de este área de los vertipuertos de dos empresas que sois vanguardia a nivel internacional dentro del área, ¿no? Vamos a pasar ahora al otro eje que comentaba antes, de la infraestructura de comunicaciones, de la mano de Ángel Alves, que es ingeniero de telecomunicación con más de 10 años de experiencia en el sector. Tras unos años trabajando en consultoría de telecomunicaciones, inició su carrera en Telefónica trabajando en diversos departamentos del área de red móvil y desde hace 6 años lidera proyectos en el área de innovación especialmente focalizados en desarrollar casos de uso de aplicación de la tecnología 5G a soluciones con clientes. Dentro de este ámbito lidera el área de conectividad aplicada a drones, llevando a cabo diversos proyectos de innovación en comunicaciones y servicios 5G para drones. Colabora también con diferentes universidades y organizaciones en seminarios de innovación y divulgación tecnológica. Y mi primera pregunta pues va en esa línea, ¿no? ¿Qué es lo que ofrece, ¿no? ¿Qué particularidades tiene la tecnología 5G para dar soporte a la movilidad aérea avanzada?
Hay que entender que 5G es el presente y el futuro de las comunicaciones. Igual que 5G está revolucionando ya sectores como la industria, otros aspectos de la movilidad, incluso la medicina, va a ser igual o más revolucionario todavía en el ámbito de los drones. Los drones conectados por 5G nos van a permitir quitarnos, en la mayor parte de las operaciones, quitarnos de una vez de la cabeza esa imagen que tenemos del mando de radiocontrol y el dron a una cierta distancia controlándolo visualmente. Vamos a poder controlar estos drones mediante 5G. ¿Por qué? Porque una de las características que me has preguntado, ¿qué características tiene 5G? Una de ellas es la baja latencia. Si conectamos un dron por 5G, vamos a poder pilotarlo prácticamente desde cualquier parte, debido a que desde que yo envío una orden hasta que el dron la ejecuta pasan solo unos milisegundos. Hasta ahora ninguna tecnología había tenido esta posibilidad de poder controlar un dron casi independientemente de donde estemos. Conectando los drones también mediante las redes celulares, lo que conseguimos es que tener una conectividad continua, poder realizar operaciones, como se ha dicho aquí, de una ciudad a otra, de forma continuada, sin perder esa conectividad. Estos son dos aspectos que nos van a permitir, pues lo que he dicho, olvidarnos un poco de controlar los drones mediante radiofrecuencia, hacerlo por 5G, controlarlos desde donde estemos. Otra capacidad importante de 5G es la capacidad que tiene para enviar y recibir datos. Esto nos va a posibilitar muchísimos servicios de realización con drones. Debido a esto, vamos a poder embarcar en un dron pues todo tipo de sensores, cámaras de alta calidad, incluso 4K, e incluso un LIDAR que transmita todo en tiempo real. Esta baja latencia, alto ancho de banda, lo que nos permite es transmitir en tiempo real, pero sobre todo, con esos datos, analizarlos en tiempo real. Voy a poner un ejemplo de un caso que estuvimos trabajando con ADIF. En este caso, era para términos de inspección de vías. Habitualmente, ¿cómo se inspeccionan las vías? Pues van dos personas andando por la vía, incluso de noche, para evitar el tráfico de trenes por temas de seguridad. ¿Qué propusimos nosotros? Usar drones. Usar drones conectados por 5G. De esta forma, lo que conseguimos fue, primero, el pilotaje veo veloz. En este caso, en una de las pruebas, incluso estuvimos pilotando el dron desde Madrid y el dron estaba operando en una línea ferroviaria en Orense. La segunda característica, el envío de datos. ¿Qué hicimos? Ponerle al dron una cámara de inspección. Aparte de la cámara de pilotaje, una cámara de inspección de alta calidad. Con esto lo que hacíamos era ir enfocando la vía, esas imágenes se transmitían en tiempo real y se analizaban en tiempo real por una inteligencia artificial que iba reconociendo los elementos de la vía, la catenaria, la señalética, etc. De esta forma, ¿qué conseguimos? Pues que, para empezar, no tenga que ir una persona visualizando todas las imágenes que va procesando el dron, sino que lo haga una inteligencia artificial y en tiempo real, de forma que si detecta algún aspecto en la vía, pueda lanzar una alarma y entonces la persona que está haciendo la inspección de forma remota pueda parar el dron y operarlo manualmente para acceder a ese punto donde la inteligencia artificial ha detectado un problema en la vía. Estas son dos de las características que ahora mismo tenemos en 5G que se están adaptando a los drones. Estamos trabajando también en alguna otra, sobre todo en dos temas que son el posicionamiento a través de la red móvil y las comunicaciones directas entre drones. En cuanto al posicionamiento, lo que estamos planteando, como sabéis, el GPS no es del todo preciso. El GPS, en algunos casos, tiene una precisión de varios metros, lo cual no nos permite realizar algunas operaciones y a lo mejor peor en entornos urbanos como estamos hablando aquí. ¿Qué estamos planteando? Transmitir correcciones RTK a través de la red 5G. Esto es, con las correcciones RTK, como muchos sabréis, lo que se consigue es corregir las imprecisiones locales que tiene el GPS y conseguir un posicionamiento centimétrico. Esto lo podemos hacer y lo estamos planteando que nuestras estaciones base 5G se conviertan en estaciones GNSS que puedan transmitir estas correcciones a los drones para tener ese posicionamiento centimétrico. Por otra parte, estamos trabajando también en el posicionamiento desde la red, un posicionamiento que ofrece la red 5G y que es alternativo al GPS. De esta forma, el dron no es que no nos envía ninguna información, sino que simplemente por estar conectado a la red 5G sabemos dónde se encuentra. Esto es muy útil en temas, por ejemplo, si el dron tiene algún problema con el GPS, temas de spoofing, de hacking, etcétera. Nosotros, independientemente de lo que nos diga el dron, podemos saber dónde se encuentra. Y por último, el tema que, bueno, en este caso lo vamos a probar este año, vamos a acabar un proyecto con correos en el que vamos a trabajar en hacer la entrega de paquetes con drones. Lo que pasa que con este posicionamiento preciso, que lo que nos permite es que el dron va a estar ubicado de forma precisa, le va a transmitir al dron que también está ubicado de forma precisa dónde tiene que ir y entonces va a depositar este paquete de forma correcta. Y la segunda línea en la que estamos trabajando son las comunicaciones directas entre drones. Actualmente no hay un estándar de comunicaciones directas. En 5G sí lo tenemos, porque 5G lo que ofrece, 4G, 5G, lo que ofrece es un estándar, el CV2X, para comunicaciones. Este estándar está pensado sobre todo para el mundo de la automoción, o se pensó en un principio para el mundo de la automoción. Esto es, un coche frena y le transmite de forma directa al de atrás que ha pegado un frenazo y le salta una alarma para que el coche de atrás también frene. Estas son comunicaciones sin que pasen por la red, de forma directa. También para, por ejemplo, vas a acercarte a un semáforo y el semáforo, si va a cambiar de color, ya te avisa de forma directa a tu coche que se va a poner en rojo, porque ya sabe dónde estás. Esto es lo que hemos pensado, este es protocolo de comunicaciones CV2X, lo hemos pensado a la aplicación de drones. ¿Para qué? Para que los drones se puedan comunicar entre ellos de forma directa. Un proyecto que estamos viendo es el que los drones transmitan continuamente su posicionamiento, de forma que si dos drones se están encontrando o se van a cruzar, tengan la inteligencia suficiente y sepan dónde está el otro para poder evitarse. Esto también lo tenemos pensado, por ejemplo, en una situación de emergencias, también en el entorno urbano. Pensemos que hay una manifestación, hay un desastre, etcétera, y tiene que llegar la policía o bomberos y quiere establecer una zona restringida, una zona en la que, pues por seguridad, no entren drones a volar. Pues estamos trabajando en una baliza que emita con este protocolo CV2X, que también entienden los drones, para decir, bueno, aquí hay una zona restringida donde no puedo entrar, así que tengo que modificar mi ruta o tengo que pararme, etcétera. Todo esto con comunicaciones directas y, sobre todo, con un protocolo de comunicaciones estandarizado y estándar, que ya están utilizando los vehículos en el ITS, en el Intelligent Transport System. Y esto es un poco de forma resumida, porque no hay mucho tiempo, las ventajas que ofrece 5G o la aplicación de 5G al caso de uso de drones.
Muchas gracias. Realmente la infraestructura 5G abre un mundo de posibilidades, es una tecnología habilitadora para la movilidad aérea avanzada y para múltiples servicios asociados y tipos de empresas de distintos sectores en ese ámbito de las aeronaves no tripuladas también. Y precisamente uno de los puntos que comentabas de ayuda a la localización de la propia aeronave nos enlaza con nuestro siguiente invitado, que es Carlos Hernández, director comercial de Telespacio en España, es ingeniero aeronáutico por la Universidad Politécnica de Madrid y MBA por el Robert Kennedy College. Gran parte de su vida profesional ha estado ligada a las aeronaves no tripuladas y a la navegación por satélite, con numerosas publicaciones en ese ámbito. Ha sido miembro del Centro de Excelencia de Aeronaves No Tripuladas de AESA y coautor del libro blanco de I+D+I para la aviación no tripulada en España, publicado recientemente. Actualmente coordina el Grupo Europeo de Estandarización de Eurocae relacionado con la aplicación de SORA, requisitos de seguridad operacional de los UAS en la categoría específica, incluyendo la navegación. Y precisamente por ello va mi pregunta: ¿cuáles son los retos a los que se enfrenta la movilidad aérea urbana en relación a la navegación? ¿En qué situación se encuentra el estado del arte?
Nada, buenas tardes y muchas gracias, Iván, por la introducción y también por la oportunidad de venir a esta mesa redonda y poder compartir un poco nuestras experiencias, ¿no? Por un lado, yo siempre me gusta empezar con un caso, digamos, con casos reales, ¿no? Cuando hablamos de movilidad aérea urbana, tenemos, por ejemplo, el caso de ciudades como Sao Paulo, que hoy en día tiene, antes del confinamiento, las últimas estadísticas eran que tenía del orden de unos 400 helipuertos operativos y más de 700 helicópteros prestando servicios, ¿no? Desde el punto de vista de la navegación, la mayor parte de estas operaciones se hacen en condiciones visuales, ¿no? Con unas implicaciones que eso tiene, ¿no? Para poder volar en instrumental o de alguna forma que es lo más parecido a lo que digamos hoy en día estamos considerando en este ámbito, pues por ejemplo, aparte ya no solamente de tener unas ayudas a la navegación suficientemente fiables, también debemos tener una cartografía urbana fiable, ¿no? Hasta el punto de que esa cartografía urbana tiene que estar también certificada, ¿no? Y un proveedor que garantice y asuma la responsabilidad civil, digamos, de lo que hay por detrás, ¿no? Me ha gustado mucho la presentación de Marta sobre la parte de seguridad aérea, etcétera, pero hay un término que no ha aparecido, digamos, en toda, yo creo que en todo el seminario, es la parte de responsabilidad civil, ¿no? Detrás de cada certificación de un proveedor de Airspace, de una aeronave, de un Telefónica que, digamos, que da un servicio increíble, tal, tiene que haber una responsabilidad civil, ¿no? Y esa responsabilidad civil, la propia normativa de la Unión Europea te pide que esté respaldada por un seguro. Entonces, si no somos capaces de convencer a una compañía de seguros de que nos dé una póliza para cuando haya un accidente y poder pagar 200 millones de euros, 500 millones de euros de indemnización, pues seguiremos siempre, digamos, como bien comentaba antes, ¿no? En ese punto de comenzar pequeño, ¿no? Porque no sabemos, digamos, cuándo el modelo de negocio va a llegar, ¿no? Resumiendo un poco, digamos, 4 grandes retos que han ido apareciendo a lo largo de todo el seminario. En cuanto a la movilidad aérea urbana, diría lo siguiente, ¿no? Por un lado está la estructura del espacio aéreo, ¿no? Ha aparecido varias veces en las diferentes mesas redondas y presentaciones. Por otro lado tenemos la separación de las aeronaves, ¿no? Teniendo en cuenta que en el Airspace o en el ámbito de la movilidad aérea urbana van a coexistir aeronaves no tripuladas que llevan personas, taxis aéreos no tripulados, digamos tripulados pero sin piloto, con piloto remoto, helicópteros, aeronaves convencionales y también drones, ¿no? UAS, tenemos realizando operaciones de transporte de paquetería como FlyingBasket, ¿no? Tenemos también asociado a la separación de aeronaves la parte de resolución de conflictos, es decir, es un tema capital que tampoco, digamos, hemos hablado quizás lo suficiente, ¿no? Y por último tenemos lo que es el cumplimiento del plan de vuelo, ¿no? Que es el contrato del operador con el proveedor de servicios de navegación aérea y también con los que proveen servicios digamos, a través de los vertipuertos, ¿no? Estos 4 grandes retos tienen un denominador común, ¿no? Que es conocer la posición de la aeronave en todo momento, en tiempo real, con una gran precisión o con la precisión adecuada a la fase del vuelo. Y finalmente, con un nivel de integridad o confiabilidad en la misma suficientemente alto para que desde el punto de vista de safety el riesgo sea asumible, ¿no? Ese nivel de probabilidades estamos hablando en torno a 10 a la menos 7, 10 a la menos 8, 10 a la menos 9. Entonces no estamos hablando, es decir, es mucho más probable que nos toque la lotería, ¿no?, en Navidad, realmente comparado como 10.000 veces más a que tengamos un accidente aéreo, digamos, usando estos sistemas, ¿no? De momento, ¿no?, salvo que Telefónica nos quita el negocio, digamos, con el 5G frente a GNSS, ¿no?, digamos, hoy en día el pilar que se considera en el ámbito de la navegación, pues son los sistemas como GPS, Galileo, EGNOS, ¿no? Bueno, en la regulación europea sobre Airspace no está, el servicio de navegación no está regulado como tal, sería un servicio complementario, ¿no?, pero no obstante, no por eso deja de ser menos importante, ¿no? Digamos, aunque para ciertas fases del vuelo y para espacios aéreos de baja densidad de tráfico, bueno, pues volar solamente GPS con algunas ayudas podría ser suficiente, ¿no?, porque hablaríamos de errores de navegación del orden de algunas decenas de metros, ¿no?, 30, 40, 50 metros. Como bien ha apuntado antes, ¿no?, en zonas de alta densidad de tráfico, que es lo que se espera en un futuro, tenemos que bajar a del orden de metros y en las fases de aterrizaje-despegue incluso a nivel centimétrico, ¿no? El tema del RTK tenemos que hablar después tú y yo, ¿no? Entonces, hay un aspecto importante y es la tendencia es a hibridar sistemas, ¿no? Es decir, tanto GNSS, visión artificial, por ejemplo, por reconocimiento de objetos singulares, ¿no? Y esto también tiene que tener un impacto en las capacidades que un vertipuerto tiene que ofrecer a sus clientes, ¿no? De qué ayudas o qué sistemas de navegación ofrezco para que una operación autónoma de aterrizaje tenga lugar, ¿no?, en condiciones de, no sé, de un viento de cruzado de 10-15 nudos, en condiciones nocturnas, etcétera, ¿no? Entonces, todo eso también, digamos, tiene que impactar en lo que un vertipuerto ofrece, ¿no? Y habrá vertipuertos que ofrezcan unos sistemas de navegación o ayudas más avanzados, como hoy en día un aeropuerto tiene un ILS categoría 3 para operaciones de aterrizaje, ¿no?, pues prácticamente con cero visibilidad, ¿no?, o un ILS categoría 1 o sin ningún tipo de ayudas, ¿no?, solamente en visual, ¿no? Entonces, eso también es un aspecto, digamos, que también enlaza con la parte de los vertipuertos, ¿no? El GNSS también tiene sus vulnerabilidades, ¿no? Tenemos el tema del spoofing. Por ejemplo, hay un evento que se pone mucho de referencia, es en Hong Kong en el 2018. Se hizo una gran demostración con 40 o 50 drones de estos, bueno, que salen a volando de forma coordinada, hicieron un jamming intencionado y los tiraron todo abajo, ¿no? Entonces, bueno, pues eso da una idea un poco de las vulnerabilidades a las que nos enfrentamos, ¿no? Pero luego también tenemos que el entorno urbano también genera una serie de reflexiones de la señal, digamos, que a veces puede provocar un cierto comportamiento errático en las prestaciones que da el sistema, ¿no? Santiago me mira, el famoso multipath, llevamos años y años hablando, ¿no? Pero es cierto que es flexible y que permite, digamos, también la fusión con otras tecnologías y que hoy en día es, digamos, lo que se asemeja más a lo que podría ser un sistema de navegación certificado o certificable por EASA y por las autoridades, ¿no? Es decir, la fusión con un 5G, que es otra de las vías, digamos, que realmente hay que explorar y que Telefónica ya nos ha contado que están trabajando, el paso es, oye, y cuando voy frente a EASA, de punto de vista de safety, y cuando voy frente a EASA, de punto de vista de la responsabilidad civil, eso ya son palabras mayores, ¿no? Hay que demostrar ese 10 a la menos 7, ese 10 a la menos 9, ¿no? Además, en el ámbito, digamos, para cualquier sistema de navegación, dado que un aspecto clave es la resolución de conflictos y en nuestro grupo de Eurocai trabajamos mucho en la parte del detect and avoid, ¿no?, para evitar conflictos en el ámbito, digamos, tanto colaborativo como no colaborativo, hay un aspecto clave, es que todos los sistemas trabajan con una predicción de la trayectoria, digamos, de una aeronave, digamos, para ver qué es lo que va a hacer en los siguientes 30, 40, 50 segundos, ¿no? Esa predicción se ve influenciada por el comportamiento del error del sistema. Si el error es de un tipo, tiene una respuesta en frecuencia u otra, tu predicción puede ser muy divergente o muy estable, ¿no? Y eso, por ejemplo, hoy en día apenas se ha trabajado a nivel tecnológico, ¿no? Entonces, bueno, la parte de navegación también es un reto apasionante, ¿no? Nosotros, desde el punto de vista de Telespacio, somos la única empresa europea que está involucrado en la operación de EGNOS y de Galileo, los dos grandes sistemas. Llevamos más de 20 años trabajando en estos ámbitos, ¿no? Y bueno, por eso lideramos este grupo de Eurocae, estamos en diálogo con EASA, con todos los agentes, ¿no? Y bueno, pues estos son los retos a los que nos enfrentamos, ¿no?
Muchas gracias, Carlos, por darnos tu visión. No podemos dar todo por sentado, ¿no?, en el ámbito de la localización de la aeronave, ¿no? Y bueno, y veíamos que asentía Santiago a muchas de las cosas que comentaba. Santiago también tiene una experiencia importante en el ámbito de la navegación y vamos a poder hablar ahora acerca de las operaciones que tú también exponías ahí como ejemplo, el caso de Sao Paulo, con operaciones de helicópteros en visual, y de eso nos va a poder hablar también Santiago Soleil, que acumula más de 20 años de experiencia en la implementación de operaciones PBN, Performance Based Navigation, basadas en sistemas de posicionamiento global GNSS. Trabajando en la industria como ingeniero de sistemas satélite, trabajó con la Agencia Espacial Europea en la fase de definición de Galileo. En el año 2000 trabajó con EUROCONTROL, dando soporte a la introducción de los servicios GNSS en la aviación civil y sus primeras implementaciones operacionales. Ha venido gestionando múltiples proyectos de la Comisión Europea. Actualmente es CEO de la empresa PILDO Labs, que está liderando la introducción de operaciones basadas en GNSS para aeronaves de ala rotatoria. Y como chairman del grupo de trabajo FLAG, promueve la armonización a nivel europeo de la implementación de operaciones de baja cota para aeronaves de ala rotatoria, facilitando así la integración futura de las aeronaves eVTOL. Bueno, hemos hablado de vertipuertos, infraestructura terrestre, pero también ha apuntado ya Carlos el problema de la estructura del espacio aéreo y demás. ¿Cómo crees que se puede avanzar en ese sentido? ¿Cuáles son los retos principales, bajo tu punto de vista?
Bueno, primero de todo, muchas gracias, Iván, por la introducción y muchas gracias. Felicitar al proyecto IMOV 3D, ¿no?, y a los centros tecnológicos participantes por la iniciativa y por atraer el talento que está en la mesa, ¿no? Yo me hubiera quedado escuchando. La verdad que yo estoy aprendiendo muchísimo de los compañeros de la mesa y, bueno, ha sacado una conclusión que la probabilidad que me toca la lotería es grande. Porque si podemos poner aerotaxis volando, pues según entiendo de Carlos, nos va a tocar la lotería. Básicamente yo lo veo que en el mundo confluyen muchos temas, ¿no? Es como intentar un mundo muy grande, transformarlo en un mundo pequeño, ¿no? Ferrovial ha presentado y AERTEC, ¿no? Los vertipuertos son como mini helipuertos o mini aeropuertos. La gestión del espacio aéreo se reduce en un USpace. Todo evoluciona, las aeronaves vienen mejor equipadas, con mayor autonomía. Luego es una evolución continua. Y a veces me sorprende, ¿no?, cuando digo que hay este tipo de modelos de negocio, ¿no?, que se va a basar un poco en navegación visual, ¿no? O sea, estamos intentando... llega un momento en que las capacidades de autonomía que tienen estas aeronaves nos tienen que permitir ir mucho más allá y crear las condiciones para que estas aeronaves operen 24/7, o sea, que no tengamos que cancelar un vuelo porque hay una situación meteorológica, ¿no? Carlos ha presentado también... Tenemos la capacidad de dar una robustez al mapeo de las ciudades, tenemos una capacidad de robustez a las comunicaciones y tenemos una capacidad de las aeronaves mantener un tipo de prestaciones que no conocemos todavía. O sea, un poco el reto en que nos estamos enfrentando ahora es un poco este proceso de aprendizaje de qué le podemos pedir a estos vertipuertos que han hecho un trabajo fenomenal, ¿no?, lo que pedimos a la infraestructura, pero cómo vamos a integrar estas aeronaves en esta infraestructura de forma segura, ¿no? Aquí, evidentemente, sistemas pues, como EGNOS y Galileo, por supuesto que tienen algo que aportar. RTK, GNSS, pues coincido con Carlos que nos tomamos una copa luego y lo hablamos, pero que evidentemente también tiene que aportar. Yo creo que sistemas redundantes, imprescindible, que haya un sistema que dé esta cobertura a las situaciones que ha mencionado Carlos, pero también es importante que nosotros podamos definir unos corredores donde tengamos la certeza que la aeronave se mantiene con una seguridad suficiente, ¿no? Luego, para hacer este tipo de trabajo, nosotros como diseñadores de procedimientos y crear estas aerovías, el mayor reto en que nos enfrentamos hoy en día es en conocer qué capacidades estas aeronaves pueden plantear, ¿no? Nosotros ahora mismo estamos diseñando procedimientos para helicóptero en espacio G, no controlado, y estamos trabajando con un nivel de prestaciones que cuando nos aproximamos a LILIUM o a volocópter, pues evidentemente lo primero que te indican es que no me sirven, ¿no? Luego tenemos que iniciar este trabajo de poder caracterizar la navegabilidad de estas aeronaves, poder crear seguramente otra manera de gestionar estos corredores, O sea, un avión o un helicóptero, o un avión no se aproxima igual que un VTOL, ¿no? Cuando hablamos con gente como IJAN, ellos hablan de una U invertida. Luego hay un proceso incluso de los sistemas de aviónica que tienen también que avanzar para poder definir estos corredores de manera óptima, ¿no? Se ha hablado también de sostenibilidad, o sea, todo lo que es la propia energía del VTOL para gestionar estos corredores pues es imprescindible, ¿no? Y la posible afectación de la meteorología y la planificación. Luego, un poco, nosotros estamos abriendo un poco la puerta, ¿no? Porque, aunque parezca difícil de entender, pero los helicópteros hoy, cuando no hay visibilidad, la mayoría de ellos no vuelan. Lo que hacemos nosotros desde PILDO Labs es un poco promocionar estas operaciones, principalmente en emergencias, ¿no? de proveer esta navegabilidad continua con los sistemas embarcados que tienen, y creemos que esto tendría que trasladarse al mundo futuro de los VTOLs, ¿no? Pero bueno, aquí hemos hablado de muchos componentes de infraestructura que me parece que es un puzzle que tiene que ir encajando todas las piezas, y nosotros desde la parte de organización y definición de infraestructura aérea, pues ahí estamos invirtiendo para que sea posible.
Muchas gracias. Efectivamente, habéis comentado como factor limitante las operaciones visuales y, claro, en ese sentido vosotros tenéis experiencia con helicópteros que se puede ir trasladando, ¿no? a este sector, ¿no?
Sí, es un poco lo que comentaba, ¿no? Es un mundo nuevo. Lo que estamos haciendo, tenemos la tendencia de copiar lo que se está haciendo en aviación y intentar replicarlo en el mundo del urban air mobility, ¿eh? Por otro lado, tenemos gente que viene de abajo, ¿no? Yo veo siempre como un sándwich, ¿no? Que viene del mundo de los drones pequeños y que quieren volar un procedimiento con una serie de waypoints. Luego aquí tenemos un trabajo, las normas de navegación, las SERA, tienen que evolucionar, y yo creo que hay un gap entre lo que es VFR y IFR que es demasiado grande, y yo creo que hay un trabajo importante en aproximar, que no sea blanco-negro, ¿no? Que se permita también esta aproximación gradual, ir ganando confianza en lo que es la operativa visual, pero que podamos explotar al máximo la capacidad de esta infraestructura que tanto AERTEC como Ferrovial van a poner en marcha, y la capacidad de aeronaves como LILIUM y este tipo de eVTOLs.
Y desde el punto de vista de esos corredores aéreos que comentabas, ¿cuáles cree que serían los requisitos que se impondrían sobre las aeronaves eVTOL?
Bueno, Carlos ha apuntado algunos ya, ¿no? Yo creo que disponer de una redundancia de la navegabilidad y disponer de una seguridad de que se pueda mantener una integridad, la certitud de saber en todo momento dónde está la aeronave, ¿no? Y la perspectiva, la situación posicional por parte del piloto o el autopiloto, es importante. Luego yo creo que lo principal que se le tiene que imponer hoy en día a los VTOLs es que sean capaces de demostrar que tienen la capacidad de mantener una serie de prestaciones. Luego, en función de estas prestaciones, vamos a estructurar el espacio aéreo, ¿no? Y vamos a ver, pues como decía Alberto, creo, pues si podemos integrar este vertipuerto en este entorno urbano, no solo desde el punto de vista de las OAS, de la propia infraestructura, sino también de las capacidades de la aeronave de aproximarse de forma segura al objetivo, ¿no?
Muy bien, muchas gracias. Santiago, no sé, Antito, si tenemos tiempo para preguntas del público. Una pregunta.
¿Alguien quiere hacer una pregunta?
Sí, soy Juan Besada, de la Universidad Politécnica de Madrid. Tengo no una, sino dos preguntas muy cortitas. Vale, las dos para Telefónica, ¿vale? Será eso, como soy ingeniero de comunicación, por eso voy para allá. No, la primera pregunta es, has hablado de que el posicionamiento 5G, que era de alta precisión, ¿de qué números estamos hablando, más o menos?
No, eso quería aclararlo porque lo ha dicho mi compañero, y me viene bien que me lo preguntes porque lo quería aclarar. El posicionamiento de 5G no va a sustituir en ningún caso al GPS, va a ser una forma de cotejar el GPS. Va a ser una forma, es decir, el GPS nos dice que está aquí, nosotros desde la red decimos que más o menos está ahí, ¿vale? O sea, no va a ser tan preciso como un GPS, mucho menos como un GPS con correcciones RTK, que ahí sí que ya estamos hablando de casi centimétrico. Pero sí que es verdad que con 5G lo que promete el estándar, porque el estándar, aunque estamos empezando a implantar ahora 5G, tiene muchísimo recorrido, sí que promete un posicionamiento de a lo mejor decenas de centímetros o incluso centimétrico en algunos casos, pero es que depende de la situación. Por ejemplo, en entorno urbano, donde hay más estaciones base, el posicionamiento va a ser más preciso. En entorno interurbano, donde las celdas son muy grandes, va a ser más impreciso. pero en principio no se espera que sustituya ni por mucho al GPS.
Sí, la segunda pregunta tiene que ver, bueno, yo también soy miembro de GUTMA, que es una asociación de los sistemas UTM, y en esa asociación tienen montada una especie de equipo de trabajo conjunto con la GSM Alliance, en el cual están tratando de definir una serie de estándares que llaman de Advanced Air Mobility, que no sé si estáis utilizando también en Telefónica o simplemente estáis quedándoos con los protocolos que has comentado, los CV2X. Si sois conscientes de estas iniciativas.
Pertenezco a uno de los grupos que has comentado. Lo que pasa que ahí sí que se están definiendo, a ver, es como se está definiendo a lo mejor lo que se quiere proponer al estándar. Y nosotros estamos ya usando lo que ya está propuesto en el estándar, lo que ya se puede, o sea, hay que pensar que desde cómo funciona el 5G, la evolución, se hacen unas propuestas, se evalúan, se aprueban en plenarios y al final hasta que lo implementa el suministrador, los fabricantes de equipos, es que pasan años. Entonces, nosotros lo que estamos usando, el CV2X, es una tecnología que ya se está usando, que lo usa el Intelligent Transport System, o sea, se usa para coches conectados. Y entonces lo que queremos es aplicar eso al mundo de los drones, más que nada porque ya está. O sea, porque ya te puedes comprar un chipset que tiene esas capacidades. Entonces, y aparte ya hay economía de escala. Entonces, no es algo que esperemos a futuro, sino es algo que estamos probando con tecnología ya actual.
Muchas gracias. No tenemos tiempo para más. Para mí ha sido un placer moderar esta mesa con los profesionales del más alto nivel y muchas gracias por compartir vuestra visión con todos nosotros.
Continuar y aguantar el último tirón. Después de la última mesa habrá un vino español y algo de picar, por si os anima a quedaros. Bueno, vamos a comenzar la última parte, antes de la clausura. Si podéis ir tomando asiento, os lo agradecemos.
No sé si me oye. Vamos a continuar, si no os importa. Estar ahí. Bueno, vamos a seguir con la tercera mesa que nos queda. Como decía Antidio, antes de permitirnos ese pequeño aperitivo, si queréis, los que queráis seguir comentando, por favor, podéis salir fuera de la sala y seguimos con esto. Te podéis estar en la parte de fuera y nosotros seguimos aquí. Así. Es que esto soy yo poco. La hacemos en inglés, ¿verdad? Estaba previsto hacerlo en inglés. ¿Cómo? Estaba previsto hacerlo en inglés, ¿no? Sí, creo que sí. Okay, so we continue. Thank you for the remaining people. I think this is going to be a very interesting roundtable, so you are going to enjoy, for sure. The fact of being here is going to be a positive thing for you today, believe me. This roundtable is about advanced air mobility technologies, and in that sense we are present the 4 technology centers that participate in the initiative iMove 3D. First of all, I'm going to do a quick introduction about the initiative itself. iMove 3D is a project that is part of the Cervera program promoted by the Ministry of Science, Innovation and University in Spain. In it, we participate 4 technology centers, FADA CATEC, ITG, AICIA, and NAITEC. The project basically aims at developing advanced technologies and functionalities, providing a disruptive solution to the huge challenge of autonomous aerial mobility and the field of intelligent transport. We have two main focus. First is achieving a high level of autonomy. The second is releasing or allowing the airspace integration. That is something that we have been discussing in the previous tables as well. For getting these points, the project itself is organized in 4 main technological objectives that are increasing the safety in autonomous and aerial transportation, integrating a large number of UAVs safety, developing intelligent cooperative system, and finally having the verification through testing and demonstration of the previous technologies. For going ahead with these points, we have in the table today with us, first of all, I'm going to do the introduction of all the participants, and later on we will do a quick presentation of the technologies of each of the centers, and later on you can ask whatever questions you have. In the first place, we have Antidio Biguria from FADA CATEC. He's a PhD from the University of Seville and it's a CTO in avionics and systems at FADA CATEC. He make his PhD in the Georgia Institute of Technology in the States. He has more than 14 years of experience in project coordination in FADA CATEC, having participated at World Packet Leader in more than 20 FP7 projects and H2020 projects. He is also he's currently the project coordinator of piloting H2020, a project that involves 40 partners and a budget of around 9 million euros. Finally, he's member of the board of directors of EU Robotics, and he led the SORA FT in EUROCONTROL working group 105 from 2017 to 2020. And basically that's all. That's not so bad. From ITG, Instituto Tecnológico de Galicia, we have Daniel Gutiérrez. Daniel is MSc in Telecommunication Engineering from the Polytechnic University of Valencia, Master in Robotics and Automation from the Miguel Hernández University. In 2016, he joined ITG as a US engineering manager. His first contribution focused on avionics and safety assurance coordination. Sorry, I have lost. He has participated in the different projects, as for example, currently I Move 3D, where AI is used to increase the safety of UAV operations. Daniel as well coordinates the research unit AIRBUS, promoted with entity data and funded by the Galician Institute of Investigation or Innovation to develop US-based services. He has participated also in CSAR BLD projects, Domus and Amulet, that currently is ongoing, as we have already here today. And finally, he's the demo leader for the Santiago of Compostela very large demonstration of Amulet. For the University of Sevilla, we have Aníbal Ollero. Aníbal is a professor and director of the GRBC Robotics Laboratory of the University of Sevilla. He is also the scientific advisor of CATEC. He is the author of more than 800 publications, being, according to Scopus, the author with the most publications in the world on UAVs. As well, Aníbal has participated in more than 180 research projects, including 41 international projects. Last but not least, he has received 28 awards, including the National Engineering Research Award in 2021, the King Jaume I Award in New Technologies in 2019, and overall winner of the ICT Innovation Radar Award from the European Commission in 2017. Finally, and sorry because I have to do it myself because a colleague of mine should be here instead of me, I present myself. This is Aingeru Barrio from NAITEC. Me. It's mechanical engineering as well with a master in aeronautical technologies and an MBA. I have participated in different projects in space and aeronautics. I joined NAITEC in 2019, and I have been acting as a project manager in different unmanned vehicle projects. Among one of those is I Move 3D. As well, I support the participation of NAITEC in the EUROCONTROL Working Group 105 and the Aeronautic Cluster EGAN in the Basque Country. So, say that, we are going to do a first series of presentation of the different technologies that the centers consider that are relevant for the advanced air mobility, and later on we will do a regular roundtable. So, Antidio, you're first.
Okay, thank you. Thank you very much, everybody, for staying here for so long. So, as we said at the beginning, why this project? Why we are here the whole day? So, basically, unmanned air mobility services. Okay, I can see the presentation. Sorry. ¿Me podéis poner la presentación, por favor? Gracias. Air mobility services can really change our lives. You know, they can save time, decrease pollution, improve citizen life in urban areas, and also semi-urban areas. And there are a lot of market study, but if we are here, also a lot of companies are also here because they expect they will create a real market, you know, in the next years. In order to do that, we need technology, you know, and we really think, and here in IMO 3D, we really think that autonomy can support the development of these advanced air mobility services. How it can be supported? So basically, it can be supported in increasing the safety. We really think that autonomy can be an answer in order to increase the safety, especially for those operations, for example, in logistics, that they are thinking about to have a pilot on board. In functionalities like detect and avoid, contingency management, for example, loss of link. If you you lose the C2 link, how you are going to handle since you have the communication with the pilot on the ground. So you need intelligence on board. And others capabilities like dynamic geocaching. And the other aspect, what we think that autonomy can also support the development is improving the efficiency, okay? So minimizing the number of operators when scaling the business, or reducing the time of service, because everything will be automatic, very autonomous, so the time to perform the service will be much smaller. In terms of Marta previously from FlyingBasket said we need 30 minutes is not enough because everything was very manual. If everything is quite automatic or autonomous, it should be a matter of seconds. So the service will be improved. And at CATEC, what type of technology? Let me check if I. Okay. We can go to the next one, please. Next one slide. Okay, so we're working a lot on fully onboard autonomy. So that means that we incorporate all the intelligence that the aerial vehicle needs on board. Like, for example, in this just video, it's just a security application that they're doing some surveillance. And the aerial robot, the drone that is intelligent, is able to automatically detect, track, in this case, the person that was doing some kind of surveillance, and then also is able to do some kind of dynamic decision making. So on the fly, the situation changes. For example, now it's going to lose the person because he's hiding, and it's going to change the mode of operation, so it's able to do a runabout and be able to try to recover the detection and the tracking. And here you can see another example, maybe in more dynamic environment. This is a video of a challenge that we did for an international competition that we collaborate with University of Seville and the Institute from Lisbon. And in here, the competition was that we have to do everything autonomous, no interaction with the pilot. At the beginning, the drone has to be able to automatically localize this. I don't know what happened. Yeah. Play the video, sorry. Yes. So the challenge is that the pilot cannot perform any operation, just press start, and the drone has to do everything with the intelligence on board. So in this case, the drone has to first look for these green balloons, okay? This is a proof of concept, and get closer and explode them, okay? This was quite easy, okay? But imagine more challenging environment, no? And this is going to come next, that instead of having fixed balloons, we're going to have a flying balloon. So you will see now a flying yellow balloon, okay? That after this one, the video is going a little bit slow, but now in the second phase of the challenge, instead of having fixed balloon, what we have is I hope you will be able to see, a phantom with a yellow balloon. And the other drone has to be able to detect, automatically track it, be able to get closer and trap the yellow balloon. Everything is autonomous, okay? So we really think that this kind of technologies, okay, this is a proof of concept, could be used for detect and avoid, could be used to dynamically understand the environment and be able to be used for this slide. Thank you. I'm going to pass to my colleague.
Okay, thank you, Didier. Okay, hello, good afternoon. Thank you all for being here. Okay, first let me briefly introduce our research center, the Galicia Institute of Technology, ITG. We are a research center located in Galicia, northwest in Spain. We are a non-private foundation, and we are a multidisciplinary research center with different lines of research. One of those is UAVs and urban air mobility, which is what brings us here. In this area, we are participating in IMOV3D, which is one of the network of excellent research center promoted by CDTI here in Spain, but we are also working in 2 other Cervera projects. One of them focused on artificial intelligence as well, which is pretty related with this topic. We are also members of several standardization organizations such as EUROCAI, ASTM, and in the past we also work within the AESA working groups to help to develop the getting materials for the regulatory. Okay. As Antonio has explained, and Gil also before, IMOV3D is about enabling the urban air mobility through the addition of artificial intelligence to the drones in order to increase the safety of their operations, to facilitate the integration of UAVs into the airspace, but also, to some extent, to promote the standardization and regulation effort, and finally to provide a continuous testing activities. In this sense, from ITG, I think that this is not a pointer, so from ITG, we are working in several pillars. One of these is adding artificial intelligence on board drones to increase the safety of their operations, for instance, in scenarios, in emergency scenarios, to enable drones to safely and autonomously landing in non-structured environments. We are also working in promoting and facilitating the operational aspect of using drones through different products that we are bringing to the market, such as drone solutions, which is focused on fleet management to facilitate and automate the management of operations with drones. We are also working, and we have also developed an autonomous hangar called Drone Safe Box to enable the unattended deployment of drones in 24/7 operations, such as surveillance operations, but also in cargo delivery. And we have a strong focus in unmanned traffic management with our partner NTT Data, where we are developing our own technology, our own US-based technology called AIRBUS, which already introduced Pablo Menendez before. And we are also actively helping in the regulation and standardization effort, as I mentioned before, as leaders of the Subpart G of Subgroup 4 of Working Group 105 in EUROCAI. And finally, we are also promoting the continuous testing of different systems through a network of test facilities and also through simulation as part of the USK project that Carlos Querejeta from BOEING introduced also before. Okay. I am going to go quickly through these slides because they have been already introduced by some other of the speakers before, such as AIRBUS, which is the US-based technology, the US-based platform that we have been developing with NTT Data to facilitate integration of drones into the airspace. Drone Suite, which is the fleet management platform that we have developed to automate and facilitate the recurrent deployment of operations with drones. Drone Safe, sorry, I said this was the slide for Drone Suite. And Drone Safe Box is the autonomous hangar that we have developed to facilitate the unattended deployment of drones in remote locations for cargo delivery and surveillance applications. Okay. As I mentioned before, we are contributing to regulation and standardization as part of different working groups in EUROCAE, HTM, but also by being partners of some of the very large demonstrators that CESARs have been funding to gather insights to promote, to develop the regulation, such as DOMUS, led by ENAIRE in 2019, and Amulet, which is ongoing at this moment. Okay. And finally, to help with this continuous testing, we have developed a network of research facilities and flight test facilities, being one of them Ancora, which is our flight center located in the north coast of Spain, which is complemented with additional nodes and additional flight node, environmental verification and flight test centers, such as the Ciudad de las TICs, which is an urban environment that we are developing for flight test in A Coruña city. And well, this is a view of our flight center in Ankara, and this is all from our side.
Okay.
Thank you.
Thank you. Next. Okay, this is Aníbal Ollero. I'm leading the laboratory of UAV aerial robotics or robotics in the University of Seville, also scientific advisor of CATEC. The lab is the leader in the world with highest number of publications in the world in drones and UAVs in general and aerial manipulation. Also the leader in the world in number of projects with active 13 European projects, coordinating 2 of them, and also an advanced grant of the European Research Council. And also we are having translating technologies to 15 companies simultaneously. I think that the topics related with the autonomous operations in a manned aerial system are some of them. So that means that planning, cooperation between different UAVs, fully autonomous landing, navigation in GNS-denied environment, obstacle detection and avoidance, low transportation and delivery. Of course, there is a number of them. We could say that many more, but also less. Why not? I mean, they are related, so we can also cluster them. So that means that this is a matter of discussion, but I think that all of them are needed for urban air mobility. So, for example, here, I don't know how to activate the videos.
Press next.
Next? Okay, this video is integrating autonomous planning, task, and trajectory of 4 drones at the same time, fully autonomous. It's autonomous cooperation, but it's also autonomous landing to recharge the battery in the mission. So we have to plan all this complex operation with several drones at the same time. We will do next experiments in Atlas next week, Friday next week. You are invited, so you are interested, you can attend this demonstration in Atlas. Also related with this, you can see the autonomous landing, because autonomous landing can enlarge the operations in many applications, in many different applications. So, for example, you can see here different landings. At the right is in mobile surface, in a ship, also in a manned vessel, but also in a car. So all these are experiments. This one was also the first in the world, landing on top of a car autonomously. And below, you can see also landing on small surfaces. There is a combination of computer vision, but also material science to have deformations of the material for the landing. And here you can see the very first landing of a bio-inspired perching with a drone. Next year, we plan to have also the perching on the electrical cables, and also we plan to recharge the batteries of the drones using the electrical light. Again, will be the first in the world. Next, autonomy, oops, I don't know how to do. Okay, now, no no GPS at all, no GNSS. How can we navigate? The solution is SLAM, simultaneous localization and mapping. This is well known in robotics, this technology. Okay, in this technology, you can map the environment at the same time, localizing the environment and navigating this environment. How to do that? So I are not, all these are videos, but in practice, I mean, the idea is to, if you are dirty, that's good. Clean is very bad. Dirty is good because you have features in the environment, and then you can match your position, compute your position. The accuracy is depending how dirty it is. Using this, we can navigate without any kind of reference, without any beacon, any landmark, in these unknown environments, including factories, including confined space, including pipes, including refineries. All these are experiments performed with centimeter, 4 centimeter, 5 centimeter map accuracy, in positioning also. Next is how to avoid collisions and how to combine planning with this avoidance in real time. So we can have many of them, first in simulation. We can have also avoid the obstacles in the environment, but also avoid between them. And you can implement these technologies in very, let's say, congested environments. Oops, sorry. Okay, it was a demo related to the experiments with 3 avoiding between them, and also related with projects in real implementations with unmanned aircraft, all of them in an environment with loss of separation, conflict related with geofence and geofence intrusion. So here, scalability and reliability are also important. And just to conclude, some small words, about low transportation. So low transportation now is good, but this was 15 years ago. We had the low transportation with tethers, and we also have the joint low transportation of sorry, I cannot activate again. Joint low transportation of a load with 3. The advantage is that in that way, you can have many of them without constraints in weight of the aircraft, and also related to the certification and so on. Many of them can transport jointly the same load. Then the problem is how to control this. And then we did in 2008 in another project. So in that case, it's reliability and accuracy. Of course, this was 2009, but now still we are trying to add reliability and how to deal with cases in which we have to deal with the emergencies. So again, solve the problem, not solve it, we still need to improve the system. So this is research result with 15 years, but still we need to increase the TRL for practical, safe implementation. So just to do that, we have created a new center in Seville. This is the new we will call CUAM, Center for Urban Air Mobility. This is new that we will plan to implement this year together, the University of Seville and CATEC. We will have, I think, good facilities, very good facilities. Then I think that we will be able to fly over the Guadalquivir River pretty soon. Thank you very much for your attention.
We have another presentation, sorry. I have broke the moment. Okay, there we are. So first, just a quick presentation. I came from NAITEC. This is a center that is based in Navarra. We are about 75 people. We are as well a very multidisciplinary center with different technology areas. And we have combined all together. We come mainly from automotive, and now we have moved to air mobility because we think that those technologies are valid as well for this application. In that sense, I'm coming to the topic of the roundtable. First of the main point that technology has to focus for understanding is autonomy. We have already talked about this. And in this presentation, you can see some of the trials that we have done using, on one side, optical means just for recognition of obstacles and doing the avoidance. We have seen as well that one of the points to be solved as well, and that can help, is just doing the fusion of different sensors just to have the possibility of operating in different conditions. And as well, using external devices for positioning. On the right-hand images, you can see this is an autonomous landing done with optical means only. And on top of that, we have later on added some other beacons just to help in the precision. It can be seen how the drone is doing the full operation between 1 and 2. It detects the position, then makes a big correction at the beginning, and later on do the landing. I want to go back. And as well, one important point in that thing about autonomy is as well having the chance of doing the verification by software analysis before doing all the trials in field. So this is another key point that we understand that from a technology perspective is important for the advanced air mobility development. And the other one is the possibility of having light structures. I mean, if you are forced to have on board different devices for your location, for detecting, for communication, and so on, having light structures is something that, it's something paramount, but this is not new. I mean, most of you are coming from aeronautics, and this is the normal day. In that sense, we have done some developments in printing electronics and embedding electronics in composite material and as well in metallics and different surfaces. What we understand allows to have very integrated system and reducing the weight of the vehicles. On the images that you are seeing now on the left, this is patch array antennas that we are now able to print over different surfaces, and allows us to tracking the antennas, reducing the weight because we are focusing the beam of the antenna to determine a certain position. So it's a very good solution for reducing the weight of the vehicle. And the other one, using as well printing technologies, is, for example, embedding the electronics or printing the wires. That is something that we are currently doing a prototype, so it's not finished, it should have been finished, but another important issues. And this allows to print even the power lines for the motors. That is, this is a lot of amps. I mean, it's not like charging the mobile, but this is through current. So we are able to print small tracks on the composites or any other material. This solution is as well possible or feasible for other aeronautical solutions. And as Aníbal has said, another key point is having the possibility of testing all these implementation devices and so in a test center. In that sense, we have developed, or we are now converting some of our facilities in Estella into a small, this is smaller, we are not so large, and a small area for doing tests internally first, and later on having the possibility of doing some checks externally, and as well having some software and hardware capabilities to allow the verification and pre-validation of the dispositives. And those are basically all the technologies that we brought. And then we have been, I think, very positive because all the technologies, we are capable, we have done a lot of things. But the question is, what is currently using the main stopper that you are seeing now? What is that point that, technologically speaking, is blocking the AAM development a little bit, and what can be a possible solution? That's an open question. I don't know if any of you want to start. If not, we can. Aníbal, Antidio, sorry.
So I think that one of the stopper probably is that we need to create the framework to facilitate the experimentation. We need to go to the real life and to do more flying testing, much more than we are doing. And this probably involves not only the capability of the centers, but also from the regulation point of view right now, you have to fulfill the same requirements for 1,000 hours of aerial works than for just 1 hour of experiment. So this probably doesn't make sense. So we really think that there should be a way to facilitate the experimentation in these test centers that we have in Spain, and because of the very nice weather conditions and the different centers that we already have, we have the infrastructure. It could be very valuable. I think this is a right now stopper. We need to find a way to fly much more than we are flying.
Well, I completely agree with Tia. This is more or less what I was going also to say. I can only add that this has to be an spiral process, starting with simulations, later moving to real-life experimentation, starting small. However, current regulation framework makes it difficult to achieve some of the authorizations, as Antidio has just pointed out. And in this sense, working in additional regulations that facilitates the setup of sandboxes to test these technologies, to gain insights about the use cases, about the business cases themselves, because nobody is going to certify or to invest in certifying or pulling higher the TRLs of their technology if they are not sure about the operational insights that can only be achieved through experimentation. So this is paramount, yes, I completely agree.
Okay, thank you. So I am an engineer and I'm a researcher, so deblocking is my job. So I just work trying to solve this. How to solve? That depends. So that means that concerning certifications and so on, our obligation is to provide information for that. So we have to deal with the engineering problem that can make this safe. I am talking about safety in this world, what means a lot of discussions and a lot of testing, real testing in many different conditions. So we need that. We need to do that. Systems will be more expensive than now, for sure. But also, I have been discussing this both because I am leading the committee related with this IEEE UAVs in America, and I was discussing, the debate was essentially the communication versus autonomy, because we consider, this was an interesting discussion, what is more relevant, the communications or the autonomy? Both, because autonomy was considered for the communication people, that's something that, the important thing is that the humans can finally take the control. But on the other hand, other people say that this will always fail in some point. So we need also autonomy. Autonomy is not a blocking point. Autonomy can try to solve the problems. Now, what we should try to provide in such a way that will be required for the certifications of these systems. Our obligation is to provide this information. So we are researchers, we have to provide this information. We have to guide the testing and finally provide the information in such a way that regulation body can do the work in a better way. Of course, they know a lot. They know much more than we know, but we have to provide the information. This is my view.
Yeah, well, if I may add something, continue with what Aníbal has said about contributing. One way in which we as industry can contribute is participating in the standardization and regulation working groups. And well, in this sense, I encourage all of you who are not already member of EuroCAE, STM, or any other standardization group to participate, because this is a good way that we have to push the regulator to provide develop the guiding material, the means of compliance needed to also enable more complicated use cases.
I fully agree on what you have said, so I have nothing else to add on that. But coming back to the autonomy and as well later on, all the presentations from AIRBUS, from LILIUM and so regarding autonomy, do you think that's going to be the next step, the next technological point that is going to be implemented, or there are other use cases, other technologies that are going to be applied faster? I mean, which is the next technology probably that is going to come to the UAVs? I mean, that's vision, autonomy, communications.
Well, I could say that the technologies which are closer to the market, if this is not a question, might be communications, as Ángel Alves from Telefónica pointed out before, but also some other technologies such as Airspace that will enable, hopefully soon, to coordinate and to facilitate the integration of Airspace, of UAVs, drones into the airspace. I think that autonomy will come later, and if we take a look to the AESA roadmap, they are talking about medium term, 2035, 2025, this term, but for sure, until
I think that the autonomy will come at different phases depending on the probably on the risk of the application. Okay? If we are talking about the new paradigm of data-driven algorithms in the certified category, I agree with you that this probably is going to be the time frame, and that's why LILIUM and AIRBUS, which are in the certified categories, because they are transporting people, they are thinking autonomy is getting very far away. But I think that the specific category and other applications that they don't have people on board is a fantastic opportunity to implement and use this technology, because these technologies, and Ivan has mentioned, they are already on the R&D sector, or the R&D from I would say a couple of decades. I mean, they have been, I would say, autonomy for cars, the late 90s and now in the 20th century, and now we are seeing how they are getting to the industry. So I think that now drones without people on board is a fantastic opportunity to implement autonomy and to make this much more efficient.
Okay, let me also have a little bit more different opinion. I agree, but I will give a different opinion. Just look into the nature. Why not? Bio-inspiration. I think that the way to do with that is bio-inspiration. We need to combine the autonomy that birds have in terms of taking decisions, having sensing, and also materials. So we need also to combine material science, as you mentioned, for example, because finally, if you just want to perch, for example, it is almost impossible to deal with only one sensor modality, one, let's say, camera, one sensor. You need to adapt, finally, the body. So you need to adapt your body to have the perching to absorb the energy in the perching, in the contact. So again, we need to combine what we consider the classical automation, computer vision, and so on, with also, for example, material science, like the animals do, essentially. This is my view.
That's a great view. Yeah, thank you. So I don't know if anyone in the room wants to make any question. And just to finalize, as we are a little bit short of time after all the delays. If not, just we can say thank you.
Vamos a tener el cierre por parte del señor Antonio Colino, que actualmente, de hecho, es el presidente de la Real Academia de Ingeniería, que generosamente pues nos ha facilitado estas instalaciones tan espectaculares para tener la jornada de hoy. Así que, por favor, señor Antonio Colino.
you have been talking English, but I think that now in the room, everyone is a Spanish speaker, no?
Yes.
I am an academician. I am taking care of the Spanish Dictionary of Engineering, and we are fighting that we have to use Spanish. And maybe in 50 years, the Americans will have to translate, no? But then, I was preparing this in English, but I would prefer to speak Spanish, as we are in the Royal Academy of Engineering of Spain. And 100 million more people speak Spanish, much more than English. There are only 400 million speaking as a native language. Well, muchísimas gracias por estar aquí. Es un tema importante y muy curioso. Yo ayer estuve en el INTA y esta mañana estaba en el jurado de los premios de los ingenieros de Teleco. O sea que estoy todo el día metido con cosas vuestras y es un tema importante. Pero en las últimas 2 semanas aquí hemos tenido a los ingenieros forestales de montes y medio ambiente ahora, con el crecimiento de los bosques. Y hace una semana tuvimos aquí, porque es el año de las frutas y de las verduras de la ONU, y tuvimos aquí a los ingenieros agrónomos. Y nos pasamos el día hablando de cosas vuestras. Pero como dicen ellos, si no hay líquenes, musgos y helecho, no hay vida. Y nos sobráis los 5Gs, la inteligencia artificial, los aves, las televisiones y todo. O sea, que veáis lo compleja que es la humanidad y lo que es la ingeniería. Que vosotros, la gente cree que la ingeniería sois casi vosotros, los relacionados con el espacio, la teleco, la inteligencia artificial, Big Data, todas estas cosas. Pero no hay que olvidar que comemos gracias a ingenieros agrónomos, porque las ovejas y los huevos y el vino, pero es que la madera y los helechos y todo eso son de los forestales. Por supuesto que hace falta ingenieros navales, industriales y de caminos y aeronáuticos, no sé qué más hay por ahí, ¿no? Minas para los recursos, ¿no? Pero que sepáis que vamos todos integrados y que vuestros grandes proyectos se pueden hacer porque hay mucha tecnología en vuestro campo, pero necesitáis, para llegar a vuestros sitios, necesitáis agua en la casa. Y eso lo hacen nuestros ingenieros. Y detrás de un enchufe de ahí, hay mucha gente que cree que la electricidad viene de los enchufes. Mucha gente y algunos ministros de países grandes. Ministros de países grandes creen que la energía eléctrica viene de un enchufe. No estoy bromeando. Lo están pagando ahora esos países, y son grandes países. Pues detrás de un enchufe hay miles de ingenieros. Pero cuando tú abres el grifo en tu casa, hay miles de ingenieros. Y cuando desayunas, si desayunas algo de comida, son ingenieros los que te lo han llevado a casa y te sientas en una mesa que es de madera. Y si usas el microondas, hay más otros ingenieros, el ascensor, coche, moto, avión, metro, ave, tren, barco, son otros tipos de ingenieros. Y claro que hace falta la tecnología, vamos a decir, de telecos, de computación, de control de futuro, control de los drones, pero si los drones no tenéis dónde aparcarlos, ni dónde tenéis aterrizarlos, y no podéis ir al campo para volar los aviones, y no tenéis agua, o sea, que la ingeniería es un complejo muy grande. Todos los grandes avances en sanidad no se deben a los sanitarios. La lucha que hemos tenido contra el COVID la ha ganado la ingeniería. Los pobres médicos les hemos mandado una lucha sin saber el enemigo, sin armas, sin munición, sin nada. Ya digo que es la ingeniería la que, cambiando a las empresas se han puesto a hacer mascarillas, que es lo de menos, pero ha habido empresas que no hacían mascarillas, han hecho billones de mascarillas. Ha habido empresas que hacían equipo y han empezado a hacer respiradores. Dentro de poco va a estar aquí una empresa española, que aunque se llame Ersil, pero es Hernández Silvino, Ersil, que ha salvado miles de personas porque ha hecho los respiradores. Y no hacía respiradores, pero con el problema, en poco tiempo consiguió hacer miles y miles de respiradores, que ha salvado a miles de españoles, pero a miles de personas en el mundo de esos respiradores. La tomografía sea computarizada en un hospital es cosa de ingenieros. Pero es que la tomografía sea por electrones o la nueva neutrónica, o es que la quimioterapia, la radioterapia, la resonancia magnética nuclear, todo es ingeniería. Y eso la sociedad lo asume, pero da lo mismo, lo reconoce. O sea, si el móvil, yo creo que el móvil, todo el mundo sabe lo que es un móvil, ¿no? y todo el mundo lo usa. La gente sabe, para que tú mandes una foto de tu niño a un amigo, a un cuñado, la de instalaciones que hay en el mundo, la de millones de técnicos que hay para que tú puedas mandar la foto del niño al cuñado, eso la sociedad no lo agradece, ni lo sabe. No sé si es porque es una sociedad muy especial o porque los ingenieros no sabemos vendernos. En Europa, en el mundo occidental, nuestros estudiantes y sobre todo nuestras chicas están abandonando las carreras técnicas. India y China egresan, como dicen ellos, más de 1 millón de ingenieros al año. En este momento, los 5 CEOs ejecutivos de las 5 mayores empresas tecnológicas, los 5 de 5, o sea, el 100% o el 1000 por 1000, son indios. Nuestros recursos energéticos vienen de fuera. Entonces, cuando los políticos hablan de soberanía, ¿de qué están hablando? ¿Saben de qué están hablando? Hablar de soberanía, si tu energía viene de fuera, toda tu inteligencia viene de fuera, incluso las chaquetas y los calcetines también vienen de fuera. ¿Qué soberanía queréis? Vosotros estáis hablando el control de los drones. Pero si al final, si todo el control lo van a tener los chinos, tú vas a controlar un dron que vuelve por aquí en la Latina. Pero el control verdadero no va a estar aquí, va a estar en China. Entonces, cuando hablemos de soberanía, independencia, producto nacional, pues que tengamos en cuenta todo esto. Porque es que da la sensación de que no sabemos de qué estamos hablando. O no vemos el problema, nos quedamos aquí. No pasamos los bordes de la Comunidad de Madrid, ni de la Ciudad de Madrid, que hay muchas más cosas en el mundo. Lo vuestro es un tema importante. A mí me pregunta mucha gente, ¿cómo van a controlar 10.000 drones volando por Madrid? Yo voy a tener posibilidad de tener un dron para mandarle a mi hijo el bollo, un bollo que hace la abuela. Esto es lo que estáis contando, que va a haber drones para hacer eso, ¿no? Que la McDonald's manda y la Amazon y la no sé qué. Y yo voy a poder tener uno para mandar a mis amigos. ¿Y eso quién lo va a controlar? O sea, que el problema vuestro, la sociedad sí que lo vislumbra. Lo que no sabemos es cómo lo vais a resolver. Pero digo que hay que resolverlo y es un problema fundamental. Ahora, no quiero daros más paliza, hay una copa y luego os permitimos, aquí hay una cola de más de 2 años para visitar el palacio. Este palacio pertenece al patrimonio nacional, es de todos vosotros, y tenemos visitas ordenadas, programadas, y hay cola de 2 años. Pero como os habéis portado bien y habéis aguantado hasta el final, hoy, si queréis ahora, después de la copa, yo lo hago personalmente, yo no hago las visitas, hay guías y azafatas y esas cosas, pero cuando hay cursos de estos, pues yo les doy una visita a Palacio, que es muy interesante y la historia de España está un poco condicionada por este palacio, porque aquí a 5 metros de aquí, 5 metros, está lo más antiguo de Madrid, ¿no? La muralla, y un poquito más abajo, y tiene 900 años. Y un poquito a 6 metros por ahí tenemos las vías de agua de Madrid, que hicieron que Madrid fuera una fortaleza inexpugnable, que luego lo cuento. Todo eso está aquí dentro. O sea, que somos la Academia de Ingeniería, tratamos de temas de futuro, el control de los drones, pero nos basamos en los 2 monumentos más antiguos que hay en Madrid y en toda la zona esta de la península ibérica. Con que muchísimas gracias y nos vemos ahora en el piso de arriba para la copa.